Hello everyone. Welcome to the Office Division. My name is Suyashi and I am the jury coordinator for this division. So it will be my job to keep us on time and I will be taking this very seriously. So our finalist teams have put in a lot of hard work. They submitted their projects, reports about a month ago, and today these teams will present their work to the jury. Let's have the jury right here. Yeah. Hello, jury members. Good
Morning.
morning.
Good morning.
Good morning.
Good morning.
So
morning,
before I
everyone.
introduce you, let me just take everyone through this. So I'm damn excited to have you guys meet the teams today. This can be a long journey for all of us, especially when we are online. So I will interrupt you guys as and when required. So please bear with me. And I really want your support in that. And please keep your comments and your questions short and crisp so that we can make it on time. So let's start with the presentations. Okay, so before we start, we will first introduce our jury members. So I'm Gyan Motnil and Madhunji, please, if you can switch on your cameras. Yes. So our office division will have 3 members with expertise in net zero and resilient buildings. Let's wait for Gyanji to join in. Okay, meanwhile, I will introduce, we have Swati Puchalapalli. Swati has 20 plus years of experience in sustainable design and computational analysis. She is a strong proponent of passive design. She is the director of Terra Veritas Consultants. Hi, Swati.
Hello, everyone. Looking forward to listening to all of you today.
Great. So let's move to our second jury member, Mr. Madhusudan Rao. He is the founder and MD of Urja Energy. He is an HVAC expert and has 4 patents filed in these fields. He has pioneered many new technologies at commercial scales in India. Hello, Madhusa.
Hello. Good morning, and all the best to the finalists. Looking forward to hearing you all.
Thank you. Next, we have Gyan Modgil. He is the founder of Sterling India. He is a second-time jury member of this division. Apart from his extensive work on green buildings, he co-founded Sustainable Tourism Council of India with a vision to mobilize stakeholders in the tourism industry towards sustainability. Hello, Gyan, sir.
Hello. Good morning, everybody.
Great. So let's move on forward. So these jury members have had over 2 weeks to review the reports submitted by the teams. They have looked at your work in detail and have already accessed your entries for the 10 contests of the decathlon competition. Students, your presentation will help them hear your narrative. They will assess your presentation and your mastery over your solution through the question and answer session. They may revise their scores based on what they hear from you today. So gear up. So for the first presentation, we will have Team Archetype. Good morning, team. How are you?
Good morning, ma'am. We are good.
Glad to see cheerful faces. All the best. So our first presentation
Thank
is
you.
by team Archetype. They have worked on Infosys building in Noida, Uttar Pradesh. Their project partner is obviously Infosys. So let's do a quick AV check for our presenters. Hi Priya, can you please say two words? Say something.
Yes, ma'am.
Great. Rishabh, please turn on your camera and mic. Your
Hello,
camera is already
hello,
there. Yeah, yeah. Great.
hello.
So Krishna,
Yes, ma'am.
great. Soumya,
Hi, hello.
okay, great. Guys, so let's start with the presentation. Please share your presentation in a full screen mode. And before you start, so I will repeat this for each and every team, that you will have 25 minutes to present your work to the jury. At 20 minutes, I will ring a signal like this. Okay, so you won't have a 26th minute, which means at 25 minutes, I will stop you and ask you to end your presentation. After that, we will have another 15 minutes for a Q&A session with the jury. Please keep your answers direct and to the point. Your project partner may also provide some comments if they are able to join. So, okay, team, the stage is yours. Let's have your presentation. So, Priya, please have your presentation. Yeah, in the full
Is it
screen mode. Great. So, all the best, team.
Good morning, everyone. We are Team Archetypes participating in the Office Building Competition Division. This is our design presentation, and we are very happy to be here as part of the finalists. Our project partner is Infosys, and we are a multi-divisional team of 12 members from National Institute of Technology, Tiruchirappalli. 10 of our members are pursuing masters in architecture, energy efficiency, and sustainability, and 2 of us are pursuing MTech in construction technology and management. Our institute, NIT, is an autonomous institute which has been consistent in an IRF top ranking list. A faculty lead, P. Gopal Krishnan, is an assistant professor at the Department of Architecture. He has been very consistent in designing multiple buildings within NIT, as well as authoring papers in the fields of conservation, urban morphology, and place attachment. Our project partner, Infosys, is the second largest IT services company in India. And it has been a consistent leader in transforming the work environment to an employee-focused, sustainable, and energy-efficient system. Our project is located in the composite climate of Noida, Uttar Pradesh. It is a build, own, operate structure. We have a site area of 40,468 square meter, permissible built-up area of 4.25 FAR. Our permissible ground coverage is 30% and proposed is 4,046 square meter. Our proposed built-up area is 21,871. Next. We have some special requirements from our project partner, that is a LEED V 4.1 rating, well standards to be satisfied, a net zero energy and water performance building, radiantly cooled and cost optimized. Other than this, we also have specific requirements for energy, water, and facade daylighting. Now, Rishabh will take over to talk about the contest that we have participated in.
Thank you so much, Maya. So to kickstart the design process, we went for a design share-it meeting where each member of the team was assigned a contest, and as a professional, we had to put ideas on the table, criticize them, and think of ways to conceptualize design. From there, the concept and design ideas took shape, keeping in mind the two major aims of a design. Story. First, to design a green office building, and next to design a value-adding process which keeps in check the well-being and productivity of the employees. Next. Concept was derived from one of our approaches, that is to bring smooth transition from work from home scenario to real-time office environments, to bring back the social and visual connect through our design. Breaking monotony, playing with horizontal levels on floor plates, and staggering of blocks was done. Next. Next, Priya. Now the question is what we achieved through this. Staggering of spaces with atrium space made it easier for the daylight to influx and also in a diffused manner. While planning and zoning, placeholder priority list was curated and their movement patterns were mapped. Conventional movement patterns were then infused with informal transitional spaces to abide by a approach. Open plan office design was chosen based on its flexibility it provides in future prospects of change, reuse, etc. Also, an application is designed to understand the employee and space interface and could be used to make changes. Next. Next, Priya. Next. Yeah. The form of the building is a simple cuboidal geometry oriented such that longer facades face north and south direction, which is played with on the interiors. Some specific elements of the building are staggered spaces, large glazings on the south facade, which runs from ground floor continuing till the ceiling, supported and shaded by louvers and space frame structures. The values to support our design and choices and the building performance will be taken up next after we have shown our plans for the same design. Priya, kindly show the plans. Yes. So these are the architectural plans which for their design flows. Next. Energy performance values will be taken up by Krishna next.
Thank you, Rishabh. Talking about the energy performance, building form and zoning was finalized after reviewing various building envelope prototypes, and longitudinal thin and open plans allowed us to arrange a variety of flexible working spaces across the floor plates with specific spatial requirements taken into consideration. And the material palette was selected based on the cross analysis of the best energy performance and affordability. The form of the building was decided after conducting daylight and energy analysis on all the prototypes. So the envelope systems which are considered are next. Horizontal shading lowers are designed on the southern facade to bring in daylight while providing protection from the summer sun and allowing in winter sun. By this arrangement, the shading devices allow daylight into the space and not the direct solar heat gain through the glazed area. And the glass used on the facade wall is double layered 6 mm thick glass panels with a 12 mm air gap. This facade arrangement with a thermal barrier between the glass panels will reduce the cooling losses and prevent heat gain, cutting down on the HVAC loads. And incorporation of the planters in our design has had multiple benefits. Some of them include increase of the thermal comfort and increase in work efficiency of the employees. Next. So coming to the load calculations, use of the radiant cooling HVAC system and chilled roof panels help in decreasing the cooling load of about 20 to 30% from base case to design case. And for the atrium spaces, use of lowered panels on the southern facade and space frame roof has helped in a decreasing of 60% of the cooling load. And for the heating load, there is no much significant increase in values in either of the cases. Next. And coming to the solar gain, the amount of direct sunlight is almost reduced to zero for all the floors between base case and design case due to the implementation of the lowers on the front facade and corridor spaces on the northern facade. And for comfort, next. And for the comfort hours, the difference in percentage in comfort hours in the base case and the proposed case are observed to be 52%. Next. For daylighting, implementation of the glass facade on the southern face of the building makes the interior spaces and atrium spaces well lit, and also the use of glass bricks in the interior parts helps in diffuse light transmission. Next. Coming to the construction materials, AAC blocks is used as an alternative material for construction. The comparative statistical analysis and effectiveness of using these blocks instead of traditional red bricks was reviewed and considered for the projects. Also, the compressive strength of the AAC block is comparatively more than the traditional bricks, and density of the AAC block comparatively less, which helps in reducing the overall dead weight of the structure. And for insulation, we considered 50 mm thick expanded polystyrene layer for the roof. Next. So in short, the active techniques which we implemented for the better energy performance are usage of high efficiency HVAC systems, solar paneling, building automation, energy efficient appliances, grey water usage, and industrial ceiling fans. And next. And for the passive techniques which are considered are the considering the importance of building orientation before and after design, and air sealing, continuous insulation throughout the roofs and walls, usage of recycled materials, usage of high efficiency windows, implementation of the rainwater collection system, and site optimization and adaptive reuse of materials. Next part will be taken up by Sumaya.
We're now talking about the water performance values that we have considered. So our aim has been to achieve a net zero water building. So for this, we aim to minimize the water consumption, maximize alternative water sources, minimize the wastewater discharge from the building, and return treated water to the original water source. So to minimize water consumption, we have low flow fixtures, waterless urinals, along with water metering and monitoring. Use of native plants for landscaping combined with smart irrigation has also helped us reduce the water consumption. Portable and non-portable water requirements were catered to by the catchments for stormwater runoff and overflow, as well as the treatment of grey water. 100% treatment of black water was used for irrigation and groundwater recharge. So by this, we have been able to reduce the water consumption by 68.96%. The total consumption is equivalent to our alternative water used and treated water return. This forms a closed loop. The main elements that helped us in achieving these targets were the reuse and recycling of water, as well as reducing the flow rates of the fixtures that we have used, in addition to using water as units. Now, engineering and operations will be taken over by Priya.
We're talking about engineering and operations by incorporating low embodied energy materials that can reduce operational cost, using BIM for increased accuracy of assessments and avoid clashing of building services, conscious planning of all the MEP services, shifting spaces with open floor planning helps to reduce the cost dismantling and increase the scope of recycling since use of movable furniture and easy installation. Dry walls and brick walls were used for interior partitions. RCC slab floor and roofing systems. Low E double glazed glass was used for facades, and AAC blocks used for envelope and exterior walls. RCC frame structure was used using flat slab construction with integrated radiant cooling system, envelope construction with partly fabricated concrete structure and partly space frame supporting the louvers. Am I audible?
Yes, Priya, continue.
Okay. Talking about the Okay, so talking about radiant cooling system, we have used a radiant cooling system, which is worked by circulating chilled water through a network of polymer pipes installed in floors, walls, and ceilings, using ceiling and floor embedded ducts, which are water cooled to modulate the indoor temperatures. The system incorporates a separate DOA system to reduce the ducting and the amount of area required for separate AHU units by combining CRCPs with floor-wise makeup air units. Talking about the resilience, the NCR falls under seismic zone 4, a severe intensity zone of having a zone factor of 0.24. Plethora of multi-story buildings in sector and highly populated urban villages, making it more vulnerable for earthquake and fire disasters. The cities are industrial hub of the NCR, and chances of chemical, biological, radiological, and nuclear emergency cannot be ruled out. So that's why the resilience to earthquake, IS 4326 1993 earthquake resilient design and construction of buildings. We use IS code IA 1893 1893 1984 criteria for earthquake resistant design structures. Resilience to fire, the fire norms were used. The building comes under office building, hence the zone 2 of fire. Resilience to COVID-19, partitions to separate working area in open office, reducing physical contact points, hybrid workstation for virtual interaction for the people working in office and working from home. Resilience to health and well-being, effective ventilation and humid control, use of colors to provide visual comfort and low glare workstation design. resilience to backup power and operations, providing emergency backup power for communication lighting devices, providing renewable energy and battery backup support to all communication equipment 24/7. Resilience to structure, shear walls, cross braces, diaphragms, and movement resisting frames are used for the reinforcement of the building. Resilience to building design. The rectangular planning was used for the design. The design and construction of the building to withstand extreme weather conditions. Design of the building is such that facilitates a personal interaction between neighbors. Uh, Resilience to basic human needs, sanitation, potable water, energy, lighting, air quality, food, health, and livable conditions are fulfilled in the design. uh, fi- a fire evacuation plan has been proposed, which in this plan we can see we have placed the fire extinguisher, fire hoses. There will be a signboards for exit directions, what to use, what not to use, etc. Innovation will be taken up by Rishabh.
Thank you, Priya. Now, coming to innovations. Since Infosys is an employee-centric company, it was very important for us to put their motivation to work apex to our priority list. The aim of our innovations was to elevate the communication between the employees in the office space during working hours and to give them a chance to self-assess their role towards the office buildings in terms of productivity and energy performance. Next, Priya. Yeah. The innovation in design is the interior staggered spaces, which help mood enhancements due to playfulness and communication opportunities. The common atrium space serves as a general space for interaction between all the spaces. Priya, next. And we are very happy to introduce you to Welsis. It was a play of words where wellness and Infosys was combined. So, an application which is derived and driven by combining employee productivity values and building performance notifications. Space and employee interface mapping, motivation quotient mapping are a part of it. Next. So, notifications such as take a small KitKat break can be received by an employee based on his or her self productivity previous analysis charts. To manage time in offices, to manage the control of the BMS system, this application can help in achieving the energy goals as well as the productivity goals of the employees and their teams. Next. So a wireframe is presented here of the application Wellsys. It also incentivizes the team as well as the individual based on their wellness and productivity values and also their fulfillment of responsibility towards the building performance. I hope you enjoy this innovative idea of ours. For our next session, it will be taken up by me only. So, talking about the health and well-being of the users, the comfort levels were enhanced by design interventions like radiant cooling from the floor instead of ceiling. Then green panels introduced in the interior. Such interventions helped us to achieve enhancements up to 25% from the base case in air-conditioned spaces and up to 85% in the mixed mode spaces. Next. As it is known that Delhi and nearby places are ill reputed because of their poor air quality, we propose installations of high efficiency particulate absorbing filters and carbon filters into the office spaces, isolated smoking zones to prevent spread of pollutants, air purifying plants like snake plant, rubber plants on the interiors, and amaltas and ashoka on the landscaping are proposed for the same. Wells's application also notifies the employees about the indoor air quality, motivational levels, etc. Proposed next. So, proposed recreational transition spaces, common spaces looking towards the atrium, staggered spaces all help enhancing the mood of the employees. Spaces like creche for the parents who have to have a experience in the office without worrying about their kids were also proposed. So we have taken care of everything which can be a problem for the mental and social well-being of the employees. and considering them through our design and process innovations. Thank you. Next will be taken up by Priya.
Okay, talking about affordability, the goal is to address the increasing challenges in the field of affordability. This is done by identifying the needs and practices and selecting energy efficient construction techniques and materials. MEP system design that will yield financial dividends in the upcoming events. Talking about finance, the office is designed as an IT service building and owned, built and operated by project partner itself. Compared to the project conducted by the project partner, it is a small building and currently they are on the stage of planning. Talking about the construction, the design aims to reduce the on-site construction time as the building form is part of a prefabricated concrete structure and part space frame supporting the louvers. The flexibility in design will provide the users an opportunity for of maximizing the occupancy and provide a more customizable, space-efficient design. The open floor plan for working station allows a fluidity in spaces accompanied by collab areas to conduct business that allows for a wide range of diverse work environments. Talking about the materials, the open plan reduces the quantity of brick and plywood that would be used to construct the interior partition, and it hence cost cutting. The doors in washrooms, storerooms, and the furniture for informal spaces would be made of reclaimed wood. Talking about the building form, the shape considered was increasing the decided estimate. So a similar and efficient design was worked on and was finalized. The revised design certifies the causes within the budget. So comparing the base case and proposed case, there was a 7% decrease in total project cost. Uh, then the decision of proposing radiant cooling system instead of conventional cooling system for the office building was taken after observing a 10.5% of reduction in cost as well as reusing the grey water for in radiant cooling. Also serves as additional efficient purpose of the arrangement. Scalability and market potential will be taken by Sumaya.
So for scalability and market potential, Noida has been a hub of hub for software and mobile development in the past decade, and it can help to contribute to the city's economy by having a presence of an Infosys building in this area. Next. So our main goals have been for adaptable design with a latent capacity to handle increased loads and cater to the growing needs as the building system can be upgraded in future. To develop an efficient construction timeline as well as systems to ensure construction productivity. For that, we have monitoring resources such as the use of BIM, virtual reality technology, and in addition to this, data collection apps to help encourage the enhanced workflows and also instant reporting. To save the time on site, we have considered prefabrication. This helps us to mitigate the labor shortage, increase cost effectiveness as well as time savings. And we have also attempted to include 3D printing on site that would help us save on the transportation as well as storage costs, and also print materials right on site, reducing the wastage and change the material sourcing. I will now be talking about communications. So our communication goals have been to create a self-explanatory design. Yeah, a self-explanatory and easy to understand design, and which appeals to all the employees. Our three main goals are to enhance verbal communication using meetings, discussions, and presentation, to convey a realistic understanding of our design through walkthroughs and 3D models, as well as BIM modeling to ensure precision in information display and avoid clash on site due to the multiple fields that are coming into play. We have aimed to promote a user-focused office, prioritize the employees' work productivity and well-being, and optimize the use of spaces. So that's all from us. Thank you for joining in and listening to our story. We are very grateful for this opportunity, and we hope you like this, and we are expecting your comments and criticism. That's all.
Thank you, team. You are well in time. In fact, before time. You have 2 minutes still left with you. The ring was for 5 minutes strand time you have. So good job there. And yeah, the app was really good idea. Okay. So let's move forward and hear what the jury has to say. Let's have the questions.
Can I stop sharing?
No, let the share stay there in case the jury has to refer to the slide so that you can go back and forth easily. Okay?
Swati, you want to go ahead first?
Yeah. Wonderful presentation. A lot of work has gone into it. It's a very interesting, multi-directional thought process, commendable effort. I think I've given quite a detailed set of comments in my reviews, so please go through that. I think some things that I'd like you to sort of primarily take away is a couple of questions actually I have got. What software did you use to do the analysis, the energy analysis, comfort analysis?
Uh, Ma'am, we have used Grasshopper with Honeybee and Ladybug plugins.
Okay. Were you able to, you've shown the, okay, you've shown the performance improvement over a base case, right? Be it energy, be it water, or be it comfort. What is the base case based on? I mean, where is the base case coming from?
Ma'am, from all the prototypes which we did the simulations in the first place, the base case was the most basic form of that, which we took up as our base case. Like it was the least working example from that those prototypes.
Okay. And when it comes to, were you able to model the whole building after the baseline block modeling? It seems that the work that you've done on a floor level, it was at a fairly basic level, right? After that, have you done detailed analysis of what kind of shading devices are required? What kind of material? So did you follow a data-driven process in arriving at the design of the shading devices, in arriving at the properties of glazing that you want to use, properties of wall, and were you able to take the modeling right to modeling the radiant cooling systems and arriving at the EPI of the building?
For the selection of glazings and the shading devices, we did an analysis on Ecotech software, and then we got the results out of it. For shading devices, it was basic louvered shading rather than giving large projections, because it was a very large glazing, so the projections would have been fairly huge, which would have been a problem for us to in the construction, as well as increasing the cost of it. Then coming to the question of getting it was all data driven. I think there was some like the question arrived because of some misinterpretations in the report itself. But then all the data was data driven. All the information given was data driven. Hello, sorry if
Okay. Yes,
I
please
don't
go
know
ahead.
if ma'am is still there.
Yeah,
Yes,
just
I'm
there.
still
Yeah,
there.
okay.
They don't
Oh,
have their video on, so don't.
oh,
Yeah,
I that was a mistake. I sort of that
no worries, no worries.
by mistake. Yeah.
So yeah, for incorporating the radiant cooling, we did have some problems at first to incorporate that in our Grasshopper thing. So we did that on a different software. That was, I think, eQuest. Then to get the total EPI.
Mhm.
But our major softwares were Grasshopper with Ladybug and Honeybee plugins. That was. Thank you.
Okay. I think it is good to know that you followed a data-driven process. I think the report didn't actually showcase the process pretty well for us to understand how you have arrived at it. Also, some of the analysis and the results of the analysis, in my experience, don't look right. So probably you'd have to revisit that, okay, and make sure that you are getting your process right. Be it the shading device, the calculation of how you arrive at a shade. Everything is calculation based. So I think it'll be good if you can go back and look at it from a analytical approach at every point in time for every single design decision. And glare, I feel comfort and glare seems to be points that you haven't managed to really achieve or meet, because those have to be more than 90%. And from what I see, you haven't reached that. I've also not seen glare from a visual comfort taken into consideration, right? So please go back if you have the time. I know you're at the end of this is the last, but it would be good because you put in so much good effort. You've come up with a very interesting design that works for that particular locality, for the problems of air pollution, uh, and at the same time providing an inside outside feel. So you manage to bridge this gap, while overcoming the air pollution. You'll have to go into details a bit more. You'll have to look at thermal comfort, visual comfort, and balance that with energy a bit more through a data-driven process. You'll have to improve on that. Okay. With this, I'll leave that to.
Okay.
I'll let Madhu take the other questions.
Sure. Yeah. So overall, very good design, building design, and you've thought through um, this in the 10 areas that you're being assessed. Um, so further to what uh, Swati mentioned, I would also stress on the same areas that in some areas where you have claimed a certain performance, especially if it is above the industry norm, it would be good to provide data backing that. For example, in your report, you have said that you have been able to achieve 750 square feet per ton. Not so efficient buildings today. I mean, an average building would be about 250 square feet per ton. And efficient ones in the industry today, industry today touch somewhere around 350, 300, 350. Good ones like Infosys ones have touched 550 square feet per ton. So when your report has something like 750 SFT per ton, a heat load calculation as to how to demonstrate that, because it's beyond what is people are used to, would be helpful. Okay, I didn't see that, so see if you can provide that. And I also heard you saying that using radiant cooling reduce the cooling load. Did I hear that correctly? If so, I wanted to understand how did radiant cooling reduce the cooling load.
So, Rishabh, would you like to answer that?
Actually, did say that radiant cooling helps to reduce whatever the load is, whatever the electrical load we are getting for cooling the whole building. That was the meaning of the whole sentence.
Okay, fair enough. Yeah, that is true. I mean, as you know, radiant cooling will not reduce the heat load or the cooling load. It'll definitely reduce the electrical
Yeah,
load.
the electricity loads,
So,
yes, sir.
yes, yes, yes. So that is good. Couple of other things. One is you also mentioned that the building will be operated in a mixed mode. I was a little curious about how you plan to operate the building in mixed mode. One of you care to elaborate a little bit on that?
This is with regards to our spatial planning, since a lot of our, right now from work from home, we are coming back to the office environment again, and there has been an increased preference of staying back home and like having a hybrid work environment. So in our spatial planning, we have included.
Sorry to interrupt. I meant in mixed mode ventilation. I think
Okay,
that's mentioned. Okay.
uh, sure.
So have you gone through it as to how it will work? Did you debate, or is it something you thought would reduce energy and you have taken it in simulation? That is fine. But operationally, from an operations and engineering standpoint, have you debated this internally as to how this will operate? Is there clarity in that? That's all I need to know. I mean, as to What was your thought process?
Yes, sir.
Was there any internal discussion on this?
Yes, sir. There was an internal discussion about this.
Discussion.
We had thought of on the northern facade, we have given like a corridor space running through and through, so that we
Mhm.
aimed at making it, and other corridor spaces as well. We aimed at making it mixed mode, so that there can be an easy ventilation, because of air quality we cannot revamp the same air again and again, and the external staircase help in ventilating the whole corridor accordingly. So that was the whole thinking process behind giving a mixed mode corridor thing in the buildings.
Good, good, good. So when you use radiant cooling, yeah, I mean, because what was coming out of the report was that you may be using that ventilation inside the building too. If you're restricting it to the corridors, that's good in terms of getting outside air and all that. But I was concerned, and I'm sure Gyanji was also concerned, if you were going to um, use the outside air directly into this space in your mixed ventilation mode. So
Yes, sir. We did
I'm
think
glad.
about it.
Yeah, yeah, good, good. That's good thought. And I found your calculations on water, its sources and consumption really thorough. Good job. Thank you.
Thank you, sir.
Thank you, sir.
Um,
If we have a little more time, I'd have a couple more
yes, yes.
points. Is
I
that
would
okay?
like Mr. Gyan is still
Oh,
there.
Modgilji is
Yeah.
here. So
Yes, yes.
you have.
See, as rightly said by Madhu, when you, it's a good approach in the sense that you have tried to use low energy cooling systems. So radiant, of course, is a low energy cooling system considered because if we look into even the office building, around 20-25% of the energy goes into fan energy itself, which is a fan energy for moving the air to cool the space, which is a larger chunk, quite a large chunk. If we leave aside the refrigeration part, the machine, chiller machine part, then this is a much larger chunk. Now, when you go for radiant cooling, almost your 85% energy is being taken by radiant. So you are only circulating the water instead of air, which is much smaller in volume. So what you do is you save in terms of energy in fan. So that is the concept of this. Now, when you use radiant, then you are cooling a surface and you have to basically seal the building not to allow any outside air. So how to first to seal the building as well as to pressurize the space so that no infiltration happens. So this is the basic concept. Now, what happens in that case is that you need fresh air, and there is a little bit of humidity added by our breathing into the space. So the fresh air also has got humidity, but that you can arrest outside the space, which doesn't come into the space. So that goes into the coil load arrested at the air handling unit itself. So you have a small air handling unit around 15% capacity, which takes part of the latent loads, which are there within the space because of our breathing occupants. Now, you see, this is an interesting answer for you to Madhu's question that when you have decreased the fan energy, so where the fan is located? Fan is located after the coil. So that heat also gets into the room heat, space heat, because it's after the coil. So it goes into the space heat. So you're what Madhu said, I would like to just elaborate because you see, when you start thinking in a different way, then that fan energy is reduced from the space load. So obviously the cooling load is also reduced. If I'm not using that much of kilowatt in the fan energy, which is 85% of the cooling load. So I am only using the fan for 15% now. So that is the part which gets reduced. So because of which the cooling load also gets reduced. But you have to be very careful with DOS. When you use the fresh air, if you locate the air handling unit at a different point, then you may encounter more energy into the fan. So that is the part which we have to create a balance. Now comes the question, basically, that when you use these kind of systems, so you have to be very careful that no condensation occurs. And how do you handle two temperatures? Because the temperature requirement which is in the slab or in the radiant slab or radiant panels, that is going to be 15 degrees Celsius or 16 degrees Celsius chilled water, whereas the air which requires is at 6 to 7 degrees Celsius. So how do you do that? So you have to basically, when you increase the water temperature, outlet water temperature from the chiller to 15 degree, you save a lot of energy because the COP goes multiple times. Coefficient of performance, the energy efficiency of the chiller is multiple times higher. But then you have to use two sets of chillers, one for the fresher DOS system, another for this system. So, and secondly, your approach was good. There is no doubt. But you have to be a little careful in understanding the basics of the systems, where to apply, and in a mixed mode, as Madhu rightly said. If you are doing ventilation and allowing the outside air, then you are ruining the system. Moisture has got a tendency to travel from higher temperature to lower temperature. So whether it's a wall, if you don't have a impervious or waterproofing layer in between, the moisture will start traveling from outside to inside and it will ruin the building. There are buildings which are kept at lower temperature than desired. Even in Delhi kind of climate, people have experienced that moisture has ingress was much more than desired. Anyway, I will stop here. It's a good approach. You have done a good work and keep it up. Thank you.
Great. Great, great, great. So
Thank you,
thank you,
sir.
jury. That
Thank you,
was
everyone.
really insightful. And yay, team, you made it.
Thank you.
So we will take another 5 minutes for the next presentation.
Yeah, Sureshi,
And
just before we move on, just wanted to add one more. We've only been talking about their energy approach and their facade design approach. I would like to talk about the other things there, especially all the multitude of resilience measures that you have thought of is very nice. And how you have planned to approach it is very nice. Your app is very interesting. I think there is potential there, and especially how you have, how I think there is potential in how you plan to measure performance and not just comfort. So I think there's a lot of potential there. So well done. You have thought it well. Thought it a think through it a little more. Go down to the details. Yeah, the devil is in the details. Yeah.
Thank you.
Okay.
indeed. Thank
Thank
you,
you, ma'am.
team. Let's
All
take
right.
Thank you,
5 minutes for the
everyone,
next
for your
presentation.
insights.
Yeah.
All the
Bye.
best.
Thank you.
All the best.
Hello, everyone. Welcome back to the Office Division. We will start with the next presentation, and that is from Team Eco Cult. They have worked on a SAT Pranali located in Chennai, Tamil Nadu. Their project partner is Team Global Logistics Private Limited. So let's have a quick AV check with the members. Hello, team. How are you?
Hi, we're doing good. How are you?
Great, great. All
Hello.
well. Let's have a quick AV check.
Yeah.
So, Preksha, please.
Hi, am I audible?
Great. Yes, you are. Abhinaya?
Yeah, hi, am I audible?
Yes, you are. Sanjana?
Hi, am I audible?
Yep. Great. Neha?
Hello.
Hey. So, all the best, team. So, before we proceed and you start projecting your screen, I have to again indicate that you will have 25 minutes to present your work to the jury. At 20 minutes, I will ring a signal like this. So, keep your ears open. You won't have a 26th minute, which means at 25 minutes, I will stop you by hook or by crook. And you will please end the presentation. And after that, we will have another 15 minutes for a Q&A session. Please keep your answers direct and to the point. If your project partner joins it, they can join the Q&A session as well. Okay, Steve, the stage is yours. Please present your screen.
I hope my screen is visible.
Yeah, we will add it as soon as you have the presentation mode. Yeah, it is visible. Off to you, team. All the best.
Thank you.
Thank you.
Good afternoon to one and all present here. We, Team EcoCult, are a group of 15 students from RV College of Architecture and Engineering. And we are extremely privileged to be a part of this journey of exploring net zero office buildings. We would like to thank our judges and faculty mentors for their valuable feedback. I, Neha Aradhya, along with my teammates Preksha, Abhinaya, and Sanjana, would be taking you through an integrated design approach. Through collective decision making and group efforts of every individual, we were able to approach and arrive at a net zero office building. We would like to thank our project partner, Team Global, which is an integrated logistics service provider that offers services in multiple segments, and also Blue Star and Pinnacle Consulting Engineers, who were our industry partners. The project, Sat Pranali, is located in PV Koval Street, Mylapore, Chennai. It is a regional office proposal for Team Global Logistics Private Limited. The site, with two-story housing to the north, Mediscan building of four-story to the south, and a city central mall opposite to it. The Mediscan building has a 3-meter setback to its north, which accommodates their fire staircase. The site lies under warm and humid climatic zone of India, having a plot area of 780 square meter and proposed built-up area of 2,486 square meter. The predominant wind direction during summer months is south and west, while that during winters is northeast. Being a built own and lease operate building of 4 floors, the upper 2 floors will be utilized by Team Global, and the lower 2 floors are to be rented out to the sister companies.
Although cooling and dehumidification are considered essential for this type of climate, initial studies showed potential of utilizing the outdoor climatic conditions to reduce cooling days through natural ventilation, increasing airspeed, and adapting passive design strategies. Referring to IMAC and considering 90% acceptability range and introducing an elevated airspeed of zero point 0.7 meters per second, the upper comfort threshold was increased by 2.5 degrees Celsius, which allowed for a mixed mode operation with about 30% naturally ventilated. The building form and design process included some of these steps: optimum ground coverage, following the continuous building area, floor plates to achieve the maximum built up area, addition of a still floor, cutouts for daylight, shade, and shadow, staircase and lift codes marked in red, green wall and noise-based power banks on the western facade, and an irresistible staircase perceived on the southeast. Optimum zoning layout helped in reducing circulation and effective utilization of the floor plate. The floor is divided as vertical circulation courts, service courts, informal gathering areas, cabins, reception, workspace area, and the main corridor space. The third and the fourth floor are for Team Global Office, while the others are rented and still show parking is provided on the ground floor. The service cores are highlighted here. Horizontal and vertical shading devices are integrated with planter boxes to the southern side. The western facade is integrated with the noise absorbing panels. The typical floor plans show the zoning and the furniture layout. We use natural ventilation for the months of January, November, and December, and the predominant wind direction during these months are from the northeastern side, which are captured by large northern windows. Natural ventilation is aided by HVLS fans that increase the airspeed. Here, you can see the longitudinal section highlighting the radiant cooling system that is being used for air conditioning and the solar PV array on the rooftop that generates the electricity required for the functioning of the building. During the nighttime, the noise absorbing panels glow during the dark and the same electricity which they produce. The southern facade is designed to integrate light shelf into the window to bring in daylight to the centermost parts. Noise absorbing and air filtering plants have been used both indoors and outdoors to improve visual comfort and air quality. As said previously, the centermost part did not receive enough sunlight and hence light shelves were added. The SDA analysis shows that all surfaces at the work plane height receive a minimum of 300 lux. Initial ASC, SDA, and new die analysis was also done specifically for the workspace area to understand the effect of the window sizes. Envelope optimization and right choice of materials and calculating U values for wall, roof, and windows helped in reducing cooling loads. The window wall ratio was carefully calculated to maximize daylighting without increasing the heat gains. We also tried using low VOC materials for the flooring and light colored eco friendly wall paints.
We have achieved an EPI of 45 kilowatt hour per square meter per year, which is a reduction of 58% from the base case. This is done by using various passive design strategies such as envelope optimization, natural ventilation, usage of shading devices, along with use of irresistible staircase, radiant cooling, high performance wall, roof, and glass, along with mixed mode operation of the building, has improved the energy performance during the building operation. High energy efficiency has been accomplished through maximum daylighting, efficient equipment, and lighting fixtures. The site receives an average solar irradiation of 5.5 kilowatt hour per square meter per day, which promises a positive solar potential. The energy consumed by the building has to be achieved on site, and this was done through solar PV panels placed on terrace. We've selected monocrystalline solar panels which has an efficiency of 19.2%. The horizontal terrace receives maximum solar irradiation compared to the building facade. Total installed capacity of power plant is 80.1 kilowatt, which has the potential to generate 1,20,485 kilowatt hour of energy annually. The extra buffer of 4% energy is being generated, which caters to the needs of increase in energy for future generation. According to 2018 report prepared by Central Pollution Control Board of India, Chennai has topped the list of noisiest metro cities, having an average noise level of 67.8 decibels during the day. Therefore, to combat this issue, along with keeping net zero energy in mind, we have developed a modular product. The noise absorbing modules are designed in two modes, one as circuits and the other as facades, the panel for the facades. The circuit system can be fixed at location with noise potential independent of the building. The panels can be fixed on compound walls to light up the streets at night or incorporated into building facade for aesthetics. These panels make use of noise and converts it into electrical energy. Solar panels, along with noise absorbing panels, make the building net zero. Another innovation which we have proposed is the terracotta blocks placed along the wind direction towards southeast. The idea of using terracotta blocks of size 300 millimeter tapering into a size of 150 millimeter void helps to reduce air temperature and maximizes airflow into the building, which in turn reduces the cooling load. It has been used as a part of irresistible staircase that acts as a breakout space, making the southeast corner cool and comfortable. This type of design, that is nature centric hangout area, promotes the use of irresistible staircase, improving human health and reducing the usage of lifts.
An effective water cycle has been developed to minimize daily fresh municipal demand. Rainwater harvesting was explored and implemented. This helped reduce the freshwater demand by more than 50%. Water is stored in underground and overhead tanks where fresh water and treated water are segregated. This stored water is used for performing daily activities. Treated grey water is used as an alternate water source for non-potable purpose and landscape irrigation. This water is further treated using evapotranspiration, and the remaining water is returned to the groundwater table through infiltration. Black water is treated using composting units. With the usage of composting toilets, waterless urinals, and water efficient fixtures, we have reduced the water consumption by 62.58% from the base case scenario of 45 liters per capita per day as per NBC to 16.84 liters per capita per day. The quantity of water stored every month is greater than the demand, hence making the office self sufficient. Chennai receives maximum rainfall in the months of October and November, hence having maximum potential for rainwater harvesting. Treated grey water is returned to the city sewer lines during these months as the ground will be saturated. Our annual water consumption is 12,30,162 liters per year, and the quantity of recycled rainwater used is 5,42,501.4 liters per year. The harvested rainwater used is 6,01,316 liters, and the treated grey water returned back per year is 1,94,430 liters. The storage capacity of our recycled water tank is 6,736 liters, and that of harvested water is 1,258 liters. Treated grey water is filtered with the help of a green planter strip drain field. Native plants with deep root systems absorb runoff and pollutants. Next, this water passes through a gravel pipe bed along a perforated pipe connecting to the stream outlet, and the remaining water is infiltered into the ground. As a part of this water is returned to the atmosphere through evapotranspiration. Black water generated from foam flush toilets is treated in composting units situated on the ground floor. Sawdust is added to the deposit from toilets. The removal of biosolids from this waste transforms it into compost, which can be utilized by the plants. The rainwater that falls on the solar panels and terrace passes through a vortex filter and then goes through ultrafiltration using 3 ceramic filters. To convert this into water fit for drinking, it is further purified with the help of UV light, activated charcoal, and chlorine. The overhead tank for fresh water, treated water, and fire water are situated on the terrace as indicated. The underground tank, along with the filtration room, are situated underground at a level of 4,200 mm below ground level. This diagram narrates the entire process of grey water and black water treatment. Water from sinks and water used for cleaning are stored in grey water tanks with 6,736 liter capacity. Then, this water is treated in a 3-stage filtration process and reused in foam flush toilet system, sensor, health and kitchen faucets. Grey water stored in the tank passes through a zeolite media filter that removes ammonium and heavy metal. Then, the activated carbon media filter removes contaminants through adsorption. Next, the 0.35 micron carbon sediment filter removes turbidity, bacteria, and viruses in which the pollutant in the fluid to be treated are trapped inside the pore structure of a carbon substrate. This is followed by a 2-stage ultraviolet light disinfection process to get rid of pathogens. Then, this water, which is fit for human consumption, is pumped to the rest of the building for reuse. A part of the grey water is diverted to the green planter strip drain field, situated along the 1 meter setback in the site, which passes through layers of porous gravel and soil, which further enables groundwater recharge through infiltration. We have proposed a radiant cooling system with dedicated outdoor air system. DOA system dehumidifies the external air and with radiant cooling cools down the internal air to comfort levels. As we are maintaining an inside design condition of 23 degrees Celsius and a relative humidity of 55%, the dew point temperature as per the psychrometric chart will be 13.68 degrees Celsius. Radiant cooling system with chilled water at 15 degrees inlet and 20 degrees outlet using surface temperature sensors ensure that the surface temperature never goes below the dew point temperature of 13.68 degrees. Hence, condensation does not occur. As per the data from the radiant cooling vendor, the surface temperature as highlighted will be 18.6 degrees and the surface temperature is about 4.92 degrees higher than the dew point temperature. Condensation is again never going to happen. We did a detailed study on the types of HVAC systems that can be used. Several analyses and simulations were done considering VRF and radiant cooling system and dedicated outdoor air system that help in energy reduction. The plant for sensible cooling includes two air-cooled scroll chillers and three 182 liter per minute circulation pumps. The plant for latent cooling includes one 2500 CFM treated fresh air unit with DX coil and two 5.5 TR condensing units. The capital cost of the VRF system is 5.07 million rupees, whereas the capital cost for the radiant cooling system is 8 million rupees. But in terms of energy efficiency, radiant cooling helped in reduction of the EPI to 45 kilowatt hour per square meter per year. Energy efficient lighting fixtures were carefully selected and several lighting simulations were conducted on Dialux Evo. The lighting load is 8,772 kilowatt hour annually. Since Sant Pranali operates as a mixed mode building, during the months with natural ventilation, we have used high volume, low speed fans that circulate the air more efficiently and effectively to the open office space, and the manager and assistant manager cabins have regular ceiling fans. The structural design of the building has been done in compliance with soil condition and earthquake loads of Chennai using StatPro software. The design is IS 456 code compliant and has been done for M30 grade of concrete and FE 550 reinforcement bars. The design employs two types of orthogonal footings and two types of typical column sections as 750 mm by 200 mm and 600 mm by 200 mm in the entire project.
According to the hazard maps of India provided by BMTPC, hazards due to wind, cyclones, and heat waves need to be considered. Even though the site has not experienced any floods yet, it is better to design the building for floods as a few surrounding areas are prone to it. Since there are no trees present close to the building, uprooting of trees due to wind and cyclone hazard will not damage the building. Still floors are provided for parking, which ensures that the working spaces are safe from floods. For earthquakes, the region falls in Zone 3, which is the moderate damage risk zone. So the structure is designed according to IS 456. The roof and wall sections with reduced U values are provided to reduce the heat gain inside the building. In order to adapt to the pandemic, an open office plan is provided with partition walls in between for social distancing. In case of grid disruptions and blackouts, solar power backup is provided. For social resilience, breakout spaces are given, and emergency exits and fire-rated lifts are provided. We have considered both passive and active fire safety measures. The plan shows the fire escape layout. 1,17,994 liters of water can be stored at any point of time, and the consumption per day is 6,736 liters. So 17.5 days of autonomy can be provided for water. The energy consumption per annum is 1,13,853 kilowatt hour, and the energy required is generated using solar PV and sound absorbing panels. In order to prepare for future disasters, preventive measures are followed. In case a disaster occurs, the recovery plan is followed until there is a return to the normal functioning of the building. Then the cycle continues. According to the recovery plan, the immediate well-being of the occupants needs to be addressed and emergency services like water and electrical supply need to be provided. Then, obstructions should be removed on the western side to permit transportation and repairs need to be conducted. We have considered a waste management system which involves segregation of the waste into 6 types. A dedicated storage space is provided for this on the ground floor. The organic waste is put in composting units and the waste is sent to nearby recycling and disposal agencies. The total project cost is 15.27 crores, which is 3.7% higher than that of the baseline cost. But the total operational cost is much lesser than the baseline project. This has been achieved by improving the building's performance through various strategies. The life cycle costing per tonnage for 10 years reduces by 10 lakhs by using radiant cooling instead of VRF system. The annual operation cost for the tonnage requirement for VRF is 12.8 lakhs. So after 10 years, the total cost is 1.8 crores. For radiant cooling, the annual operation cost is 5.8 lakhs and after 10 years, it's 84 lakhs. So the maintenance cost reduces by 57% while the operational cost reduces by 54% over the 10 years. The electric supply rate reduces by 4 lakhs every year by using radiant cooling system. This ensures that the payback for the additional capital cost of radiant cooling is achieved in 7.5 years. The main east-west corridor and secondary and tertiary corridors improve the circulation and communication in the workspace. By using AAC blocks in the proposed case design instead of bricks, the dead load reduces by 58% and the cost per square meter of the walls reduces by 39%. By keeping this proposal as a prototype and with minimal changes as per the requirements, this building can be adapted to suit the needs of users in similar climatic conditions and scale irrespective of its typology due to the open floor plan proposal. The noise absorbing panels proposed can be easily plugged onto any surface with incident noise energy across all climates and typologies of the structure. As mentioned, the panels can be used to light up the facade or used as backup energy for emergency lighting. The cost of terracotta modules in the resistible staircase ranges from 50 to 80 rupees. With faster construction, these prefabricated blocks can be inbuilt into the 115 mm thick walls facing the direction of the wind, further adding aesthetically pleasing effects to the facade and breaking the building's monotonous look. Through our Instagram account, we have been updating people with some of the concepts and ideas related to net zero buildings. We have made an impression on 7,854 users and reached 3,749 accounts while keeping 107 accounts engaged. Summarizing the main aspects integrated in our design: rooftop monocrystalline solar PV panels of efficiency 19.2%, overhead tanks for freshwater, treated water, and fire water situated on the terrace as indicated, radiant cooling system with DOAS, a floor area of 2,486 square meters, 100% comfort hours met through mixed mode and passive comfort system, lobby zone to periphery to allow natural ventilation, facade integrated noise absorbing panels, double skinned wall featuring green wall, building achieving a balance between form and function, a net reduction in life cycle cost by 30%, provision of fire protection system for emergency situations, effective ventilation system, better indoor air quality and visual comfort achieved, still floor parking system as a protection against floods, solar PV and sound absorbing panels to meet 100% building energy requirements, integration of rainwater harvesting system, and 85% daylight achieved after window wall ratio calculation. This is how Team EcoCult has designed Sat Pranali as a user-friendly, resilient, affordable, energy and water efficient office building. Thank you.
Amazing, Team EcoCult. I loved your infographic. So let's move forward to what our jury has to say. We will start with Swati.
Wonderful presentation. And it's also very nice to see a all girls presentation team. We need more women in this area.
Girl power.
Girl power, yes. Mm, really good work, really good work. And you seem to have gone through the comments all of us gave and have addressed a lot of them. Thanks for that. It's good to see you answering most of the questions that I've put together. I have a couple more. I have one major question though. There's a site context, right? There's a building, you said this building doesn't have any setbacks or there is no need to provide setbacks. And the building next to it, especially on the south, seems very, very close to it. Have you taken that and the building on the west into consideration, or was it the east in front of it into consideration? Because these are two tall buildings, and in all your calculations, that's something that I noticed that maybe you haven't considered them in your daylight calculations, shading calculations, etc.
So, ma'am, we have left a 1 meter setback towards our southern facade, southern side, and the Mediscan building that is to the south has a 3 meter setback towards its northern side, where they have accommodated their service areas. So there is a clear distance of 4 meter between the two buildings. So while calculating the shading devices, the window ratios, etc., we did consider the shadow that is casted over by the Metiscan building. And we see that it is during the early mornings and the late evenings that the shadows are predominant, while from 11:30 in the morning till 3:30 in the afternoon, we get a direct sunlight from that side because the summer suns are really high. So when we design light shelves also, we've considered the summer sun not coming in. So we get only diffused light from the summer sun, and the winter sun enters inside. So there's not heat gain.
Isn't the building on the south and not on the north? So summer sun won't be a concern. It's the wind. It's the
No,
sun
the
coming
summer
from
sun,
the
the light shelf has been designed in such a way that the summer sun, when hits the light shelf, does not hit the light shelf because of the shading, and only the winter sun, which hits the diffused light, enters inside.
Right, I understand that. If the building is only 4 meters away, then there would be a lot of shading in the lower floors, right? You would have, so please do look at it floor by floor. When you have buildings so close to each other, you need to understand, or you need to design, you need to check for shading and at every floor level on both sides. Okay. So that's one input I would suggest. And also balance the shading and daylight at every floor level would be required because of such a close building context. Even when you're looking at natural ventilation, you should look at that at a floor by floor level because it will vary from space to space. The building is very close to this one. Okay. So otherwise, it was a wonderful effort you put in. The number of questions that we have and the number of comments we have is because you have done so much work. And there's always room for improvement, right? So that's why we have all the comments. I think the water, you have explained the water extremely well. I'm glad to see that you have thought through it. I got a little confused between, you said grey water was infiltrated and you also said grey water was recycled.
Right. Yeah. So we have two options. So uh, for the recycling part, we are using it for the composting toilets, sinks, and all of that. And the remaining water that is not used by us is infiltrated into the ground.
Right. Okay. Understood. When you do that, keep in mind about Chennai's monsoons or
Right.
any site for that matter. Infiltration is very difficult when it rains,
Right.
right? So you should think about how you plan to do that.
All
Uh,
right.
okay, when
So,
it
so
rains.
during the monsoon months, we were thinking of letting back the water to the city sewer lines since the
Hmm.
soil is saturated already. So
Hmm.
that was the solution that we thought of.
Yeah, the sewer lines would already be quite inundated or would be, overstretched. So, for a building where you're talking about resilience, you need to think about how you minimize your load on the sewer system, especially during those times when it rains.
All right.
Okay, all right. Just a few comments. Then I really enjoyed going through your report and I really enjoyed going through your presentation just now. Very well done. I think a lot of my other questions that I had put together you have answered, and I'm sure Modgulji and Madhu have a lot more questions for you.
Great. So let's have Madhu. Please, your turn.
Sure. Um, Very good presentation, and report was also very well structured. Um, I found you have given good data backing the uh, calculations that you have done. And I feel it's a very good design that you have done considering the constraints of that site. I mean, you have very limited space in which you have to build this building and incorporate all these features. I think I'm really impressed by that, and really like the use of terracotta block and noise absorption panels. Could one of you talk a little bit more how what is that you're using to convert noise to electricity?
So this was actually based on a prototype that was sort of designed by a group of 11th grade students from high school in Philippines.
Mm-hmm.
So the idea is that since the western facade, that's facing the main road, there's a lot of traffic in that area, and there's almost 67.8 decibel noise levels throughout the day. So we wanted to incorporate that into the design as well, and we thought that through these panels, and since those panels have this membrane within them, the noise that's coming from the road vibrate the panels, so there's mechanical energy created, and this is stored as electrical energy in batteries, and in the night it can help to sort of light up the facade, or even if there's any emergency lighting required, this source of power can be used for that.
Good, good. Almost like the reverse of a stereo box, right? I mean,
Yeah, it's a
the
reverse of a
diaphragm
speaker.
vibrates, reverse of a speaker, right? Good, good thought. I really like that. Really like the way you have dealt with the wastewater and treatment of how you're dealing with the grey water that's coming out of it. Only one concern I have, but before that, I wanted to ask radiant cooling that you have considered in this. Is it a floor or a ceiling cooling that you have considered?
We've considered ceiling cooling.
No. And you also mentioned that for the 30% of the operating time, you plan to use this in a mixed mode, right? So I would just caution you there, considering that Chennai weather and how much humidity is there, and the hot and humid air usually is towards the top. I would just ask you to relook and see if you can use floor cooling, and if possible, uh, maybe avoid mixed mode, uh, especially in a place like Chennai. But if you have data which backs that, I would really be impressed if this building can be operated in a mixed mode use. There's a lot of humidity that comes through. I would ask you to relook at the dew point if you can calculate, and in how many hours in a year the dew point is below the surface temperature. You explained that the surface temperature is about 4 degrees to 5 degrees above 18.5 degrees, right? So
Yes, sir.
let's say it is 22.5 degrees centigrade. Just see how many hours and then you need some buffer, right? If the surface temperature is you definitely don't want 18 degrees surface. So I'm assuming surface temperature is 22 degrees or 22.5. You need some buffer. So as long as the dew point of the air is above, right? What do you call 24, 25 degrees centigrade, you should be fine. Just check in how many times in a year that is possible. So that'll give you the answer if you have not done that. That is my only comment for you to just relook at your design. But otherwise, I think everything is really well done. Congratulations for the work.
So to answer the natural and mixed mode operation, we did a detailed simulation for the 3 months, that's January, November, and December, to understand the air movement and what will be the humidity levels with natural ventilation. And we found out that they lie in range of 55% to 60%, which seems comfortable. And even the indoor temperature are also reduced. And we had enough cross ventilation and air changes per hour. We also had a concern about how is it practically possible, and hence we did speak to a few people who live in Chennai, who work in offices, and the response from them we have incorporated into the design, and that's why we went for a mixed mode operation.
So again, I'll just stress, I understand the RH may be 55%. Just look at the dew point. That is all I'm asking. That, that'll give you the answer, okay, whether it is complete.
Thanks.
Okay.
Okay,
All right.
great.
Thank you.
So let's move on to Gyan. Lastly, over you, please.
A very well presented and a very detailed thought process has gone to. Only few things when you get into a group, then some kind of integration parts at times we start missing. You know, uh, only 37% of your area is air conditioned. Rest is not considered out of the built up area because the tonnage which you have considered and the area per ton you have considered, only 37% of your building is air conditioned. So please look into that, whether that is correct or not. And when you are giving the performance specs of your building, there you are mentioning some U values and some SHGC. But when you are going to the project design, proposed design, there you have changed those U values and SHGC. So why is it so? Because you have to be consistent. So please look into these things where by sometimes we do miss into while going into the report. But one thing which I could not understand is that you have said 10 square meter per person. So it comes to around 249 people. So, and your total daily consumption is 3368. You said you have reduced to 16.4. Now it comes to 13.5. But when you're treating the water, 3368 and 12 lakh 30,162 liters, it is exactly 365 days. You are treating the entire water. Whereas if you are considering reduction and allowing that water to come in, you may reduce the use of fresh water, but overall use remains the same. So you need to understand that how to strike the balance or how to kind of work out these things. You know, if we all of us want to reduce the water consumption. So, but water consumption, say 45, I can reduce to say MOEF gives me certain kind of guidelines to reduce it to 29, 30. All right, I go to 29. But then out of that 29, if I am starting recycling, then how to do that? So that also remains a question mark that we do need. So if the entire water is coming, if you consider this 45, then it is 11,000 liters of water which you need every day. And then even in 200 days, you will go to multiple times. So please look into these things when you present something that yes, consistency do remain. Then, as Madhu pointed correctly, I think if I heard you correctly, you said during air conditioning temperature, you will maintain 23 degrees Celsius inside space temperature. If it is correct, then it is very difficult to get 23-degree from radiant cooling. That is number one. One should not attempt that because the surface temperature is at least 22, 21 max. Now, from 22, 21, if you can achieve that kind of temperature and comfort, it's not possible. So you have to attempt for 24 plus at Swati will say 26. Let me be honest with you. She will not say 24 even. So at least 26 if you are attempting, and you have mentioned very rightly the mixed mode temperatures, which goes to 30-degree also in the month of June and July. So which is again when you present, then you have to understand what basically consistency should remain because all of you were working, might have been working in different groups, and then you kept on presenting and then put it together. So, what we try to say is that as a team, you have assembled, and it is a teamwork which is going to achieve the final end result. And all of us say, all minds put together in the very beginning, all kind of things taken into consideration, right from concept, including services, safety, fire, whatever you have done is an excellent job. But remain consistent and do integration. That is what I think will take you to the final winning point. Thank you.
Yay! Great. Thank you, jury members. And thank you, Team EcoCult. So you're finally through this? All excited? Yeah, smile. Come on. So thank you, everyone. We will move on to the next presentation. We will have a 5 minutes break before that. Thank you, EcoCult.
Thank you.
Hello.
Hello, Team Grey.
Hello.
Hello.
Okay, we will have a quick A/B check. So, okay, before that, let's introduce you first. So, our next presentation is from T Grey team. and they have worked on Pragya 2, which is located in Gift City, Gandhinagar. Their project partner is Savvy Infrastructure Private Limited. So let's have a quick AV check. So Prasanna, please say something. Unmute yourself. You're on mute.
Yeah, mute.
You're not audible, Prasanna. Okay, meanwhile, Prasanna is. Yeah, comparatively. Can you increase your volume?
Yes, hello.
Yeah, speak a bit louder. It's quite less. Okay. Okay, so Tarun, please say something.
Hello, ma'am.
Great. Hafsa?
Hello, ma'am.
Hey. Hi, Narayan.
Hi, ma'am.
Okay, great. Seems like we are good to go. So can you please present
Prasanna,
your
you're
screen?
muted.
Yeah, Prasanna, last time, let's see. Say something.
Hello, ma'am.
Great.
Is it good now?
Please present your screen, Team Grey. Share your screen and go in the presentation mode.
Is it
So before you
visible?
start, yeah, let's go through the checklist, and that is you will have 25 minutes of time frame, right, to present your work to the jury. At after 20 minutes, I will ring a signal like this. You won't have a 26th minute after that, which means at 25 minutes, I will stop you and ask you to end your presentation. And after that, you will have another 15 minutes for a Q&A session. Please keep your answers direct and to the point. So let's proceed. The stage is all yours. All the best, team.
Thank you, ma'am.
Thank you. Hello and good afternoon to all. We are Team Grey, a multidisciplinary team from JNFAU or SPA Hyderabad, and it is an honor for us to be here. We have worked for the office building division of Solar Decathlon India, and I, Prasanna, along with my teammates Hafsa, Tarun, and Narayan, will take you through our design. As population continuously increases, so will the urban areas and businesses, bringing growth in construction of large buildings that continue to negatively impact the environment. So, we partnered with Savvy Group to design a green office building which can help add to the sustainability goals of India. Savvy Infrastructure Private Limited is a non government company that believes in changing the paradigm of the construction business by adopting innovative technologies. And we also had our faculty leads, Mr. C.H. Srinivas, Mrs. Shristi Srivastava, Mr. Uday Shankar, and Ms. Meghna Malik, who guided us through this project. Our project is situated in Gujarat International Finance Tech City, also called Gift City in Ahmedabad, and it is the planned business district in Gujarat, India. The site is in a commercial cum residential zone which is mostly under development and is a little over a kilometer from the Sabarmati River. Our project brief provided by Savvy calls for the development of a 15-storied commercial complex designed to follow the principles of sustainable green buildings and comprises modern, flexible, and efficient office spaces. Some requirements that they asked for are 5 elevators for seamless access and a 4.2-meter floor-to-floor height. Ahmedabad has a subtropical semi-arid. Here we have shown a year-long temperature and relative humidity chart, where we can see that the temperature ranges between 2 and 44 degrees Celsius, and there is 0 to 23% relative humidity throughout the year. The major winds are from the north and the east.
Coming to architectural design, we were given an site area of about 11,000 square meter with permissible ground coverage of 65%. After form evolution, our ground coverage came down to 41%.
In this figure, we can see the main division of spaces in our building. Most offices tend to be compact and stifling. We wanted to stray away from the conventional building type and make the spaces more livable. We did so by adding greenery and lounge areas for the employees to take a break from their hectic work cycles, creating seamless circulation for our users and making the spaces more adaptable. Our form evolution happened in 4 stages. We started off with a plain block the size of our permissible ground coverage and then added a service road which made the block a bit smaller, bringing ground coverage to 41%. We then created an atrium through the middle of this block for better ventilation and daylighting. We carved out the form to create self-shading, reducing the area of surfaces exposed to direct sunlight. Next, vertical circulation cores and green pockets were added for better air quality. Finally, we incorporated a louver facade system that creates shading and reduces heat gain. A base block has evenly transmitted solar radiation on all the faces. After our form evolution and self-shading optimization, we managed to reduce the direct solar radiation on all the faces of the building. We provided various office sizes for the companies to choose from. We added vertical circulation cores at 3 major points of the building as shown by the red color in the zoning diagram. We added horizontal circulation. We added ample horizontal circulation for easy access. As you can see in this floor plan, the red arrows indicate the movement of the people from the cores to the office units. As the intensity of the color changes, you can see a gradual transition from public areas to more private ones. The offices are sized 200, 300, and 400 square meters for our tenants to choose from according to their own requirements, ranging from 16 to 44 workstations. The floor to ceiling windows give an open and lively feeling to the offices. At site level, we made use of pervious light colored paving and bioswales, both of which are techniques used to collect and filter stormwater runoff. At our landscape, we used Indian beech trees, which are more commonly found in Ahmedabad and have a high air pollution tolerance index.
We used floor-to-ceiling glazings on the external walls with a window-to-wall ratio of 36% to reduce the solar radiation while trying to keep the visual comfort. We planned a louver facade system. We tried 4 different iterations of louvers on an external facade. First, we started with basic vertical louvers extruding 250 mm from the wall spaced about 2.6 meters from each other. The result achieved showed no major results. In second iteration, we tried horizontal louvers extruding 300 mm from the wall and spaced 0.85 meters from each other. This iteration had relatively better results in the south, but no major result impact on the other 3 facades. In third iteration, we decreased the spacing between the horizontal louvers on the south face and tried a combination of horizontal and vertical louvers on the other sides. This was a better, more efficient, but needed more adjustments. After several adjustments, in the final iteration, the horizontal louvers towards the south face were spaced at 250 mm from each other with an extrusion of 125 mm from each other. And a dense combination of horizontal and vertical louvers on the other side were tilted by 22 degrees towards west. As the glazing system, we have tried multiple glazings present in the market and finalized on 6 mm double low E glazing argon filled glass. With these combination, we have finalized our facade system with horizontal louvers on the south, blocking the major portion of the sunlight, and combination of horizontal and vertical on the other faces. Working with industry partner, we have tried to come to an optimal louver system which is relatively economical and give a good result.
As Gift City is a global financial and IT hub, 28% of the land distribution is dedicated to commercial businesses and the financial sector, which is our main target audience. By making use of the amenities provided by the city as well as locally available materials, we reached one step closer to reducing construction and operational costs. About 150 large Indian and global companies have already started operations in the city. These companies have invested about $1.5 billion and provided employment for more than 10,000 people. This also opens up various opportunities for expansion of commercial businesses and building types. Our office spaces would be available for lease for such companies. We have incorporated an integrated building management system, which is a scalable and innovative integration of HVAC, fire safety systems, public address, access control, security, lighting, and other systems. All of these essential building operations can be controlled by a building automation system software. The benefits of this include energy savings, enhanced building security and safety, flexibility and user convenience, and reduced operational costs. This attracts more tenants, especially the bank and financial sector, which demands additional security and efficiency. We have used building information modeling software to plan, design, construct, and manage our buildings. The construction timeline is calculated in segments as shown in this table. We have chosen peri-formwork solutions for our building construction as they guarantee efficient, fast, and safe construction.
For the health and well-being of the occupants, we have focused on three main areas. They are thermal comfort, visual comfort, and indoor air quality. For thermal comfort of the occupants, we ran thermal radiation simulations and we have found that the most of the spaces are above a 96% comfortable on a typical summer week and 76% comfortable on a typical winter week. Further, we have arranged our furniture layout according to our simulation for optimum thermal comfort to the occupants in their working hours. For the improvement of indoor air quality, we have integrated few strategies to our design, such as filtration of the air using HEPA and ultra-low penetration filters in certain areas respectively, condensation control by using recommended R values, reduce the moisture damage to the ceiling. To ensure the visual comfort of the residents, we ran few simulations with and without louver system and have found that we reduce the glaze around the periphery of the office, we maintaining the spatial daylighting with only minimal reduction. In the lux simulation, we can see that we increase the areas with comfortable lux levels, and in the radiance simulation, we can see that the solar irradiance around the building facade is significantly reduced.
For resilience, we aim to design a building that remains functional even during times of stress or disturbances and is resilient against seismic, hydrometeorological, and public health hazards. So, we analyzed the potential risks and came up with strategies to overcome them. Ahmedabad runs a risk of moderate intensity earthquakes, for which we used a strong frame RCC structures and PT slabs. It is also an area liable to floods with a probable surge height of approximately 3.5 meters. So we planned adequate drainage systems and raised essential equipment rooms to higher levels. For electricity issues, we have used our solar PV system, which can generate electricity. And in case of fire hazards, we have an extensively designed fire exit system along with proper signage to help the people. Drought is also a possibility, and our grey water reclamation system, although it does not solve the problem, can keep the building running for the next 3 to 5 days without issues. We can see here the overhead and underground tanks which will be used at these times. For water performance, we began by cutting down our daily water consumption. We did this by using efficient fixtures, and then we studied our potential water sources. We could not rely solely on rainwater harvesting since it would only be feasible for 4 months in a year. So, we also focused on reusing water on site with a sequencing batch reactor. This allows 75% of the grey water to be reused. We developed an efficient water cycle that ensures water supply, grey water reclamation, and fire safety. It effectively uses and reuses the water to its maximum potential before it goes to the sewage treatment plant. As for our tanks, in the underground we have a freshwater tank, our water treatment plant, our treated water tank, and the fire safety tank. They send the water to the respective overhead tanks to be used by the building. Although we could not achieve net zero due to the very large number of users in our building, we managed to cut down the water consumption by 61%. Construction affordability is identified as one of the main issues associated with sustainable construction. The cost of our proposed design is 3.35% greater than the baseline estimates. Installing efficient fixtures and a more architecturally efficient structural system increase the initial costs. However, after analyzing our life cycle costs for the next 25 years, we found that our building can save 1.55 crores in operational expenditure every year. This reduction of 13% in life cycle costs was achieved through optimizing our HVAC system, architectural design interventions, network lighting, water management system, and our building envelope optimization.
Night flushing. Night flushing is a strategy used to cooling down the building interiors via lower external air temperatures in the night. It employs the building's thermal mass as an intermediate storage medium, allowing the structure to absorb the heat buildup during the day and flush it away during the night. Since Ahmedabad has an average diurnal range of 11.5 degrees centigrade, the night flushing system has a good impact on reducing the heating loads inside the office spaces. Using thermal mass of the exterior walls, we could decrease the temperature of the interior spaces before the building operation starts to reduce the cooling load of the HVAC system at the beginning of the day. In the design, we have incorporated an openable window element which would be opened up in the closing hours. The hot air is sucked through the hot air exhaust vents and then is replaced by cool air through the openings as shown in the graphic. The aim is to optimize the energy efficiency of the project by reducing the heating and cooling loads, integrating daylighting and passive systems, as well as low energy and efficient cooling systems. We have choose a 6 mm double low E glazing SKN Envision glass as it has a low SHGC values and relatively good VLT values so that the heat gain would be reduced significantly. For wall assembly, we have used a 200 thick AAC block as provided by the project partner because of this local availability in the market. We have tried to make it more efficient by adding layers of a 15 insulated plaster and a 3 reflecting coat. It is also economical and has a low U value as compared to a normal AAC block. For efficient usage of the resources, we have used few strategies such as network lighting controls, which helps us save up to 47% of the energy. This used time scheduling, occupancy and vacancy control, personal control, daylight harvesting, and load shedding, which are all enabled by IoT. This type of lighting control uses wireless switches, eliminates the switches directly to the fixtures, and these fixtures convey the information of the broken or burnt out lighting at a real time. The HVAC system used is a Blue Star air-cooled screw chiller system for the electric from the electric and district cooling system. We have incorporated a district cooling chiller system for our HVAC as it is 20% more efficient than a conventional HVAC system due to its partial load operations, speed modulation, zoning capabilities, and heat recovery technologies. We have optimized the HVAC by using effective heat load calculations and ducting. We have developed a model so that we could create differential pressures in the ducting, which would result in proper circulation of the air, and it also helps us control the HVAC systems. We have worked on the heat load calculation from the E20 sheets carefully to have a effective HVAC system. The overall HVAC energy consumption has been brought down from 65 lakh kilowatt to 23 lakh kilowatt from the measures measures provided above and the central district cooling system. The average solar radiation of the Gujarat state is 1266.52 watts per square meter. We have used solar PV cells as an renewable energy source. A 1 kilowatt peak solar rooftop plant generates an average of 5 kilowatt hour of electricity per day over the year, considering a 5.5 sunshine hours. We are, with the available rooftop area, we are able to achieve a plant size of 337.3 kilowatt. The solar PV system used panels of 1980 mm into 1080 mm integrated solar PV roof with an efficiency of 22%. For designing the solar PV system, we have considered a 5.5 hours solar radiation per day, producing a 320 wattage per panel. The baseline EPI of our office with the ECBC standards was 141 kilowatt hour per meter square per year. We have reduced it by 14% by optimizing the building envelope system by bringing down the EPI to 121. We have used efficient by using efficient equipments, IBMS system, and network lighting. We could further reduce the equipment and the lighting loads to 23%. The optimization of the HVAC by effective designing and using the Gift City district cooling chillers and the shading devices, we could further reduce our EPI, resulting to a final EPI of 49.58 kilowatt hour per meter square per year. The final EPI calculations have been calculated by using the energy loads of the efficient equipments, network lighting system, and final HVAC loads as shown.
We also presented our works to other colleges, departments, and faculty and took feedback from them. For our online reach, we shared constant updates and information about work on social media platforms. Overall, these are our goals and if or how we achieve them. For energy performance, we aimed for an EPI of 80 and achieved an EPI of 49.58 kilowatt hour per meter square per year, which is 65% lower than the base case. For water performance, we aimed for net zero annual water. We could not achieve net zero, but we reduced annual water consumption by 61%. In architectural design, we aimed for functionality and aesthetic appeal with flexible office spaces, which we achieved through our design. For resilience, we aimed to maintain functionality in the face of stress or disturbance, and we achieved it through our structural, fire safety, and water system. We wanted our building to be scalable in the target market, reducing costs and construction time, which we achieved through a thorough market study, IBMS, and building construction optimization. For affordability, we wanted thoroughly evaluated and justified costing. We achieved this and also reduced our lifecycle costs by 13%. For health and well-being, we aimed to improve air quality and thermal and visual comfort. We achieved this through simulations and air quality strategies. For engineering and operations, we aim to integrate the high-performance systems seamlessly, and we achieved it through our design. For innovation, we aim to identify and create solutions for specific problems in the area, and we did this through night flushing and our louver system. And finally, for communication, we made clear and concise reports and engaged with the public about our work. Our team comprises 14 students from the architecture and FSP departments of JNFAU. We work together both offline and online throughout this competition with the help of all the people from STI and our faculty. And these are the softwares that we use throughout our work. Lastly, we would like to thank Solar Decathlon India, our project partners, our industry partners, our faculty leads, and everyone who guided us through this process for providing us with knowledge and guidance throughout this learning experience. Thank you.
Great, guys. You finished off well in time.
Thank you.
So let's hear the jury's comments and take questions from them. Good work.
Thank you.
Let's start off with Swati.
Good work. Very well presented. Very clear and concise. Few things that stand out. I was wondering whether you managed to actually. I went to your report. Very interestingly put together. You have considered a lot of various things, and you have managed to integrate the 10 contexts quite nicely. Having said that, I have a few questions and a lot of questions that I have mentioned in my comments. Please sort of go through that and see how much you can answer. One question I have is comfort. When you were modeling or showing the comfort related analysis, thermal comfort. Thermal comfort is not just based on facade or envelope. Thermal comfort is actually based on, as you know, a combination of facade, internal conditions, etc. So why only the layouts? That's one question. Second question is daylight. When you are analyzing for daylight, you didn't seem to have considered the internal layouts. So your daylight analysis seems to be too good if you put that together with the internal layouts that you have come up with. So these are a couple of questions. Of course, there are other questions related to how you manage to achieve the wall U value of 0.23 with just 200 AAC block and a 15 plaster. It seems too good to be true. If that's possible, then that would be a magic plaster out there. Then the fourth question I have, let me put it. Okay, let's answer these and I'll get to the other parts.
For the thermal comfort, when we are like for the in the presentation we showed like we only used for furnitures and layout. But when we were focusing on thermal comfort, we were thinking about the air pressure inside the building and so air velocity inside the building and complete air temperature. So even we tried out different layouts of blocks, like the blocks which we have for office, like 300 meters per second, 400 meters. We're trying to change the spacing of between them, and we were trying according to the simulations, like changing different by various iterations and. But even when it comes to daylighting, we were even using furnitures while placing the while we are trying the daylighting simulations and glare simulations and various simulations which we were trying towards this iteration. So we not only furnitures, we were also trying for the layout of the building and even like how we are going to arrange the zonings between the spaces. And
so daylight, I noticed that your daylight in some of your office, some of your spaces, your external facade is covered by a cabin, more or less. 70% is covered by a single cabin. So the rest of the deep floor plate doesn't have access except for 30% of that facade. So that's what I mean when I say that maybe you haven't considered internal layouts in your daylight analysis. And simulation based, how did you arrive at the simulation based thermal comfort? What is the basis? What kind of inputs went into that layouts? What kind of parameters did you consider? I think that's important when you put together a layout or you show something graphically like that.
during like while we were discussing about our internal layout and during our simulations, we first in the starting we were trying to put the all cabin office like the way how we are trying to show the first like public places and we are going into the semi-private and getting to the private areas like offices and conferences halls. So we were focused first, we were spacing around that. Then again after that we tried to see how they're working in our simulations according to our daylight and all. and because of the window, and that's why we try to use a complete floor to ceiling glazing, because of the there was less space, as you said, for the entrance of the working areas and all. So that's why we were trying to do simulations on in different spaces according to the thermal comfort, not only thermal comfort, according to the this how much disturbing it is for working areas. And even we try to put those furnitures like, far away from the uh, glare, how much glare that is disturbing and all. That's according to that we try to arrange our furnitures, and according to that we try to furniture our arrange our layout, internal layout of the
Okay.
office.
Okay, that's good to know. That's good to know. Um, the walling, how did you achieve that U value?
For like when we were trying for AAC blocks, when we got around zero point 0.8 for AAC, sorry, 1.6 for AAC blocks. Uh, so when we were trying to figure out how can we decrease the U value, and how can we more decrease the load inside, sorry, thermal load inside of the wall, sorry, material. So we were trying to figure out what all materials can be used and all. So we were trying out simulations in this design builder. So when there was some options how can we add layers on the walls, on the blocks, and how, so that will reduce the U value. But there was some problems coming we were facing according to the I was facing while doing some simulation. But at the end it was around 0.48 when we added this reflective coating. So and at the end we thought about like insulating the walls also for office, because these are working spaces. So there will be less noise. There will be more noise reduction. So we use the insulated wall, and it it it, it showed it like it was 2.4. Like we were not fixed.
It's not correct. Okay. So please, I think you should be a little more careful when you just never take anything at face value, never take any vendor details at face value. Always cross check. Go back to your go back to the baseline calculations. Understand what you're putting into a model. Okay. It's very important to not take anything at face value. Okay. You said that you managed to achieve 61% reduction in water. Is it 61%? If you have net zero, you're saying that you have managed to reduce water consumption by 61%, or have you managed to meet 61% of your freshwater requirements with
We cut down.
baseline compared to?
Sorry. We reduce the amount of water that we would take from the municipality if we didn't use these systems by 61%. Like for only the freshwater requirements are taken from the municipality, and rest of them are generated on site, like with grey water and rainwater harvesting methods.
Okay. All right. Okay. All right. That's good to have that clarity. Okay. Well done. I think I'll let Madhu and Modgilji ask the rest of the questions.
That was an insightful comment, Swati. So let's move forward with Madhu.
Sure. As I really liked the way you've done the space design, and I was impressed by the amount of work that you have put in assessing what is the right way to put the lures. I always wish more and more people who use lures for their buildings. Definitely reduces a lot of heat load. Um, I have a question. You had mentioned you're using water for HVAC. So where is this water being used in HVAC?
In
So the
the
waters are directly coming from the district cooling unit, so we don't have to provide the water like from our site, but you would have to pay for the amount of usage that we have done to the gift cities.
Fair enough. I just wanted to confirm. So you're not using any water for HVAC,
No, sir.
right? Okay.
No,
Just
sir.
yeah. So just wanted to confirm because it didn't look like that from your report. So if you're using it from the gift city, the district cooling. What is the total load of this building? I just wanted to confirm that number again. Is it 90 tons for about 11,000 square meters?
Yes, sir. Through calculations, we have got a 90 ton for this whole building, sir.
Okay. So just relook at that. Seems really low for that sort of building, even with your design. Um, so just look at that. And have you? Did you do any heat load calculation, or just went by rule of thumb on this?
Sir, no, sir. Like one of our like teammate who is from FSP has done this heat load calculation from E20 sheets, and he has
Mhm.
like looked at all the like all the faces faces in different directions, and then he has come up with the 90 TR through the calculations.
Okay. So if you do 90 TR, it comes to 1 ton for about 1,300 square feet. Okay. Just give that feedback to whoever did the heat load and just ask
Yes,
them
sir.
to recheck the numbers. This
We'll
is
cross check once again, sir.
doesn't really look like something that can be achieved.
Okay, sir.
Request you to also relook at the solar radiation you have taken. You have mentioned some 1226 watts per square meter. That may
Yes,
be
sir.
peak, but even at ground, such radiation levels may be not possible. But even that, it is a peak. So I
Yes,
don't
sir.
know what you have considered, because that may be a peak, maybe for a few hours in a year out of the total number of hours. So just consider what is, you have to do monthly analysis or use one of those softwares to get the actual output from the solar system. What is the capacity of the solar system that you have?
337.1 kilowatt.
337 kilowatt. And did any of you check whether the roof is available for such for this size of plant?
Yes, sir. After removing the like chiller plant set and the lift room, this was like from the available like remaining available rooftop. We have calculated this, sir.
Okay, good, good. Just wanted to check that. Finally, I really like that your communication bit where you have gone and shown it to others and physically. I mean, I've seen a lot of people put just on Instagram, and I appreciated the fact that you have actually gone and spoken to people about your design and got the feedback in person. I really commend you, all of you, for that. So that's it from my end. Bianji.
I totally agree with Madhu. Being on the field has the most value, apart from the calculations you are doing and what you're learning. So let's move lastly to Gyan. Over to you.
Thank you. Very nice presentation. Very well done. Good work. Only few things I would like you to notice. When you talk about district cooling, that means chilled water is a given thing. So when chilled water is being supplied by district cooling system, you are installing 90 TR air cooled chiller. Highly efficient central chilled water system is being provided in the gift city, which is also Blue Star only. So you don't need to provide your own system. You only need to provide tertiary pumps to utilize that chilled water to the pressure what you need. And you are metered only for that chilled water, not for the power. So that is one question. Your built up area is around 10,000 square meters. When you are going to the energy calculations, target EPI, then your area changes to 67,500 square meters from where it has come.
Sir, actually, about 11,000 square meter is our site area, not our built up area.
What is the
That's the
built up
total
area?
site area.
What is the built-up area? 6,000?
That is no, that's total built-up area, including every all floors, and that's 67,000. The
If
one which
required,
we have mentioned need
we can
How
to
refer to
much
take.
the
built-up?
slides. Sorry to
How
interrupt.
much is the built-up area?
Team, would you like to refer to your
67,514, sir.
slides? You can project it on the screen if required. Would
How
you like
much?
to?
Yes, sir. 67,514, sir.
67,000 square meters.
Yes, sir.
And 67,000 square meter with 90 tons. Madhu said 1,000 square meter per ton. So, you see, if it is 67,000 square meters and you are using this, and then basically you are consuming 34% of your energy into HVAC alone. So, what is permissible built up area?
It's how much ground we're allowed, like the maximum amount of ground we're allowed to cover. It's our ground coverage, 65%.
See, you have mentioned permissible built up area is 4345 square meters, right? Not the ground coverage. Anyway, that's okay. Uh, that's fine. I'm only trying to say that there are certain mismatch which are there visible. First, when it is district cooling, you don't need to use any kind of chilled water plant. You have mentioned air cooled chiller, mentioned COP for water cooled chiller, COP for evaporatively cooled chiller, and COP for dry cooled chiller. And incidentally, the dry cooled chiller COP is higher than the COP of evaporatively cooled chiller. Right here, if you look into water cooled chiller 6.2 is fine. Air cooled chiller dry cooling, you have 3.69, which is higher than the adiabatic cooled chiller, which is 3.19, right? Which is not true. And then there is a star labeling which is yet to come, and that has not basically that the 6.2, if you are considering, that will go pretty too high to 5-star level. Anyway, at 90, it is not possible. 90 TR 6.2 is impossible. So I'm saying you need to understand from where you are picking the figures, and then at one point you are mentioning all kind of refrigerants. You have mentioned 410, HCFC, 2HFC, 134A, 2HFO. So all these refrigerants also you have mentioned. Why?
So
Please
those were like,
remain consistent.
yes, sir.
Pardon?
Those were like used before for the calculation without the district cooling, and then we have given the efficiency of the district cooling. Like it wasn't like before in the report we have showed like different R314 and all that. That wasn't like used in our final design, sir.
No. Final design is with what? Air cooled chiller, which is on the rooftop, you said.
Yes, sir.
So then what is district cooling doing? Because chilled water is supplied through large size chilled water pipes running into the tunnel, getting into every building. So that is district cooling. So you don't need to put your own plant. You don't
Yes,
need
sir.
to put your air conditioning plant. You see, district cooling means city itself has got a chilled water supply like the water supply. So the municipal authorities, like they give you electricity, they give you water, they give you from the district only, you're getting the chilled water also. Like in US, you get the hot water as well. So
Yes, sir.
similarly, you are getting this. So it's a given thing. Secondly, when then you are working out the power consumption, you have considered power consumption of chiller also. So chiller is not there. So you can reduce that. That's
Yes,
what
sir.
I'm trying to say. It's a good approach, but then you have to understand where you could have improved or you need to basically improve. So there are few factors which you need to consider. Otherwise, the report is very good, and that's why, because you have considered this in this manner, that's why your energy consumption on your air conditioning side is pretty too high, coming to around 34% of the total energy. So 34 kilowatt hours, sorry, which is pretty high. Anyway, a good work. Thank you. All the best.
Thank you, sir.
Thank you, sir.
Yeah, guys, cheer up. It was a good work.
Yeah.
Smile, you're on camera. So thank you, jury, and thank you, Team Grey. It was a great work, guys. So now we will take a long break for lunch. We will start the next presentation at around 2:30. We are a bit 5 minutes into the lunch break. I hope you won't mind. And Team Mitrika and jury members, we will join back again at around 2:20 so that we start off at 2:30. Okay, thank you guys.
Thank
Thank you.
Thank
you.
you. Bye.
Hi, Janaki. So do one thing. Stop projecting my screen and put that banner again. Or first stop, put that banner and stop projecting my screen. कर दिया आपने, उसके बाद ही मैं फिर यार एग्जिट करूँगी. एग्जिट कर दूँ. Cool. Okay. Let's stare at this for one more minute and then we will start. Okay. Hello, everyone. Welcome back to the office division. We will now continue with our leftover presentations. So, for fourth presentation, we will have Team Mithika. Hello, team. How are you?
Fine.
Fine.
Good
Great.
afternoon. Well,
We will wait for Harshita to come online. And please switch on your camera, Harshita. Harshita. Yeah, there you are. So we'll have a quick check, AV check for our presenters. Sayak, please say something.
hi, good afternoon.
Okay, seems great. There's a bit of echo, but I think that will work out. Priyanka?
Hello.
Oh. Okay, I think you guys are sitting together, right? Shubham?
Good afternoon.
Ah, perfect. Harshika? You're not audible. There's an echo. This will basically create a bit of a havoc at the time of presentation. So let's try and resolve that. Meanwhile, let me introduce you guys. So Team Ritika have worked on Sarda Group Corporate Office located in Raipur, Chhattisgarh. Their project partner is Sharda Energy and Minerals Limited. So before you start presenting your screen, team, you will have 25 minutes to present your work to the jury. At around 20 minutes, I will ring a signal like this. You won't have a 26th minute after this, which means 25 minutes. After that, I will stop you all and ask to end your presentation. Okay? And after that, there will be a 15 minutes of Q&A session. Please keep your answers direct and to the point. If possible, if your project partner joins in, we will have them as well. Okay? So please project your screen. It's there. Okay, great. All the best, guys. Over to you, Team Ritika.
A very good afternoon to all from Team Mithika. I am Shubham, along with my co-presenter Shayok, Harshita, Priyanka and Jatin. Will be presenting our project today. Our team consists of 8 members from SPA Vijayawada, Jadavpur University and Pondicherry Technical University. We have collaborated with Sharda Group as our project partner to design their corporate headquarters in Raipur, Chhattisgarh. We have partnered with Inner Green and Vigneshwar Air Conditioning for their expertise as the industry partner for the project. As per the projected growth rate, almost 50% of Indian population will be living in the urban areas by the end of 2050. The annual percentage change in the proportion of the Indian urban population is higher than the global average. An increased demand of urban infrastructure and the growth of the market economy is inevitable. This will aggravate the potential risk of land shortage, hyperdense fabric with an increased rate of energy consumption, freshwater demand, depletion of natural resources, and related environmental risk. Loss of sociocultural attributes and absence of human-nature connectedness is an emerging concern in the urban neighborhood. In the context of Chhattisgarh, the economic survey revealed that the GDP is higher than that of India's, with majority contribution from industrial and service sectors. Additionally, some of the studies also revealed a large disparity between the supply and the demand of energy in the state. For Solar Decathlon India competition, the vision was to address all these emerging issues through a holistic design to propose an exemplary net zero office building in the socio-economic context of Raipur, Chhattisgarh.
The proposed project is located in Amasiani, an emerging business district in Raipur, Chhattisgarh, which is 12 km away from the city core. The site is a part of Shriram Business Park,
which is an upcoming mixed-use development with an FAR approximately of 1.2 acres. As the local guidelines, the permissible FAR is 3 and the maximum ground coverage is 30%. As the site abuts a seasonal stormwater channel, a buffer of approximately 9 meters is provided toward north and west direction. The project requirements have been developed according to the client's brief to accommodate 10 different departments for 250 occupants, considering 10% visitors with an future provision to accommodate 30 more persons. The spatial allocation was done with major office spaces integrated with the shared and allied services, interactive zones, along with the recreational spaces for an estimated built-up area of 6,700 square meter and the construction area of 9,000 square meter approximately. The space were further subdivided into conditioned, unconditioned, and mixed condition spaces to reduce the energy consumption and to maximize the natural ventilation potential of the building.
As per the ECBC climate classification, Raipur has the characteristic of composite climate. To identify the right mix of design strategies pertinent to optimize the building performance, a matrix has been composed of according to the four climatic segments based on the climatic analysis. The four segments are namely mild winter, comfortable, hot and dry summer, and finally warm and humid monsoon. The strategies were tabulated and a combination of the same was integrated in the design development phase. December and January months fall under the mild winter segment, having the minimum and maximum temperature of 12 and 26 degrees centigrade respectively, while the relative humidity ranges between 40 to 75%. The months with the comfort climatic characteristics are February, October, and November months, having the temperature and humidity range from 17 to 30 degrees centigrade, while the relative humidity ranging from 45 to 70%. Strategies like natural ventilation, mutual shading, etc. are adopted for this segment. While March and June months falls under the hot and dry summers with a minimum and maximum temperature of 20 to 40 degrees centigrade and relative humidity of 34 to 65%, east-west longer axis, compact build form, shading devices, and insulation are the major consideration for this segment. July to September months fall under the warm and humid monsoon, having the minimum and maximum temperature of 25 to 30 degrees centigrade, relative humidity ranging between 70 to 90%. Strategies like cross ventilation, narrow floor plan, dehumidification, etc., have been focused on for this segment. Based on the previously analyzed climatic segments, the related high performance office building from three different climatic types were selected to identify the most suitable strategy for the design rationale, such as north-south longer axis, narrow floor plan, central courtyard planning, narrow floor plan and light shelves for better daylighting, mutual shading, shading devices, high performance glazing, low UV materials, high thermal mass, partially naturally ventilated, efficient lighting system with rainwater harvesting and efficient water fixtures.
After analyzing the site and its context, a shoebox model was designed and simulated for wind, solar radiation, and daylight availability as a part of initial form development. A compact form was developed with north-south orientation, which have less radiation and effective daylight. It was optimized into a more compact form to accommodate the spatial requirements on the site, which impacted the daylight availability indoors. Further, it was split into two separate blocks with north-south orientation to enhance the mutual shading, daylighting, and natural ventilation potential. The floor plates of south block was extended for self-shading and also to increase the terrace area for solar PV installation, while the north facade was being staggered horizontally to enhance the natural ventilation potential. A podium was provided between the two blocks as an integral space to promote social interaction. Further, the horizontal and vertical zoning of the spaces were carried out. Connectivity between blocks through staircases and bridges have been developed along with building integrated landscape for improved indoor air quality and pedestrian movement. At site level, the building block has been proposed with a landscape buffer from the adjacent road and the stormwater nala to enhance acoustic and ecological aspects. At building level, the zoning was done with the conditioned office cabins in the east having the maximum views towards the road, mixed condition workspaces in the center having the access to the outdoor green spaces, unconditioned but ventilated service areas on the western side to protect occupied spaces from the harsh afternoon sun. The podium was placed at the first floor level, which acts as a common access to both the office blocks. Jalis, derived from the local Bastar art, enhances the wind flow through venturi effect into the podium space. Open plan designing is carried out to have the flexibility in modification of internal spaces, as well as it can fulfill the requirements even if there is a need of change in the building typology in future. Circulation codes were placed in a staggered manner. The horizontal connectivity, such as bridges to the other blocks, was designed close to the circulation codes so that the employees can use both of them to access any of the spaces. The multipurpose hall, being the least used space, was placed on the topmost level and it shades the podium. Indoor sports and gym were provided below the podium level. At the rooftop level, solar PV panels have been installed and the west facade has been rendered with BAPV panels to maximize on-site renewable energy generation potential.
Landscape was envisioned as an integrated aspect of the built environment design. Extensive landscaping with indigenous palette was considered at the site and the building level. Heat and drought tolerant spaces, riparian biodiversity with vibrant outdoor spaces were focused to enhance the groundwater recharge potential, carbon sequestration, minimizing the urban heat island effect, while improving the overall microclimate, air quality, and lend rich aesthetic to the above space. At site level, following strategies were applied to maximize the ecological sustainability and also the user activity quotient, such as silent garden with nature trail, shaded outdoor workstation, spill-out zones with sensory garden, vegetable garden with seasonal fruit orchards, arrival court with landscape pockets, dense avenue plantation for shaded pedestrian corridors, permeable surface cover, vibrant plantation palette to induce rich aesthetic to the site. At the podium level, to promote social interaction and to enhance microclimatic variation, following design consideration were proposed: step plaza with seating and vegetation, flooring patterned with colored stone as metaphor of dynamic circulation or movement, featured columnar structures with vegetation, landscape court with seating. At the building level, indoor plants with outdoor green pockets at the balconies were proposed. The inner green model, an innovative hydroponic system with a requisite mix of native plants, is integrated along the office spaces as per the occupant load to enhance the IEQ potential and also to induce biophilia.
The wellness office concept was adopted. Unlike typical corporate offices, activities and breakout spaces were integrated along with the mixed conditioning areas to promote the health and well-being and visual connectivity, optimum daylight, glare control, and ventilation. Use of low VOC paints, indoor pollutant emission materials for ceiling, tiles, false ceiling, adhesive and furniture, etc. was the major consideration for optimizing the IUQ potential. For the indoor plant selection, the air filtration plant list as suggested by the NASA during their clean air study was referred to native plant list. 3 plants were selected to remove the benzene, trichloroethylene, formaldehyde, which can identify as the 3 most harmful chemicals are Gerbera daisy, bamboo palm, and snake plant. The fenestrations were optimized to maintain the AEC below 3% and the illumination of 300 lux for 83% of the office areas. The lux levels throughout the buildings were below 2000 lux, which lies within the UDR range, resulting in a very less glare. With respect to thermal comfort, it is maintained for the 75% of the hours for the unconditioned spaces, while 79% of the office spaces, that is the conditioned and the mixed condition and maintained for 100% of the hours. On an average, in a typical floor, the temperature were maintained in a comfort zone, except for the months of April, during which the temperature exceeds by 1 degree centigrade. To make the building resilient, many adaptive measures were taken in consideration. Raipur lies in earthquake zone 2, which has less seismic vulnerability. Still, is kept on the designing the appropriate structural system. Higher plane design to avoid waterlogging issues to make it flood resilient. To reduce the adverse effect of heat waves, attention is paid towards climate responsive passive design. Fire safety services are implemented in plant by providing fire staircases, shaft, etc. as prescribed in NBC Part 4. Universal design aspects are incorporated to make the building barrier-free. Self-sufficiency design to meet the energy and water demands. Different renewable sources such as rooftop solar PV, BAPV, panels on west facade, biomethanation plant, and waste-to-energy plants have been proposed. Multiple on-site renewable energy sources were proposed, generating 650 megawatts of electricity annually, out of which almost 95% from the PV panels and 2% from the biomethanation and remaining from the waste-to-energy plant to achieve the net positive energy building, which is also triggered the potential for the zero waste site.
For energy performance, a 100% air-conditioned conventional base case was considered and then optimized. The spaces were zoned into conditioned, unconditioned, and mixed condition spaces. For building material, 9 different wall assemblies were simulated and a 275 mm insulated AAC wall was selected. For roofing and rooftop shading, a 230 mm flat slab with solar PV panels was considered. Amongst the double and triple glazing simulated, a 3 mm by 13 mm argon filled low E triple glazing was selected. With respect to shading, a 0.5 meter overhang was installed on the north facade for shading with screens on the west facade. BIPV panels BIPV panels were installed on the east facade and staggering was done on the south facade for shading. For HVAC, 5 different systems were simulated with the VAV air-cooled chiller system as the base case. The VAV water-cooled chiller was selected as a final HVAC system as it is more efficient and has a higher coefficient of performance. For lighting, space-specific ASHRAE-compliant lighting was used along with lighting control. For each of the strategies, multiple assemblies and systems were simulated and the most suitable system based on efficiency, affordability and availability was selected. The base case EPI was calculated as 395 kilowatt hour per year. This was reduced to 253 after the application of zoning in the spaces. Integration of the selected wall and rooftop assembly and rooftop shading resulted in the EPI to decrease to 236 and 230 respectively. Window glazing and shading further reduced this to 222 EPI. The HVAC and lighting systems contributed to the most energy reduction, resulting in the final EPI of 56.2 kilowatt hour per year. Further, the use of eco-labeled products was recommended to the client. From the base case, the energy consumption was reduced by about 80% for the proposed case, and with the use of renewable energy sources, the building was made net zero energy. Through rainwater harvesting on site, a total of 3.7 megaliter water per year can be collected. A rainwater storage tank of 36 kiloliters, sufficient for 3 days of water consumption, have been provided. The overflow will be redirected for underground water recharge through water recharge pits. As per NBC, base case per capita water consumption is considered as 45 liters, but to reduce the overall water requirements, energy efficient fixtures are added, which reduce the per capita consumption to 27.1 liters. The freshwater demand was reduced from 7.8 KLD to 5.6 KLD by using water efficient fixtures, waterless urinals, and drip irrigation system. Further water performance was optimized by reusing the 6.1 KLD of treated water generated for flushing, horticulture, HVAC, and groundwater recharge. Therefore, the water cycle was balanced through 5 stages: rainwater collection, water extraction, consumption, wastewater treatment, and underground water recharge, resulting in 50% net positive water building. So the flat slab technique was used for better structural integrity. Building management systems were adopted for better operation and management, and waste to energy systems were installed for minimizing waste generation and offset energy consumption. The integration of RCC flat slab system instead of the conventional RCC structure resulted in a 19% cost reduction. There was only a 3.5% increase in the total cost of the proposed case in comparison to the base case after the integration of all the building design strategies.
The USPs of the project can be defined as a two-tier approach. The vertical tier addresses the net zero office building as per energy, water, and waste. The horizontal tier addresses optimized matrices for adaptive comfort. A climate-responsive framework was formulated that can be replicated as a flexible model in a similar climatic zone, or can be used as a tool to optimize the solution in a different climate to achieve net zero efficiency. Material scalability can be triggered by the use of locally resourced material with an emphasis on recyclable content and healthy indoor guidelines. Translation of the indigenous cultural attributes such as the use of regional Bastar art as shading screens into the built environment can trigger the niche market scaling of the target population. The building was designed to cater specifically to the target population through architectural innovation. This was achieved by presenting an interactive space design showcasing vertical, horizontal, and visual connectivity and breakout spaces. Our team has tried to reach the mass population to convey the ideas of net zero philosophy and sustainable building design through different posts on social media platforms. That's all from us. Thank you for your time.
That was real quick. Good work, Team Ritika. Your presentation was really amazing. I should say that. And I was really hooked on it. So great work here. So let's move on to the jury and their comments. This time we will start with Mr. Madhu, please.
Sure. Thank you. Um, Good design, and I see a good amount of effort was spent on the climate analysis even before designing the building. Really appreciate that, and how from that it emerged uh, that you have to extend the south facade so that there is self shading. Uh, that was good. So, use of jalis to let the air in for ventilation was also good. Um, I have few questions related to solar PV. You mentioned solar PV generating 650. What is the amount? Megawatt hours or megawatt? What did you say?
581 megawatts.
581. Is it megawatt hours?
Team Ritika, if you want, you can present your slide if required. Let us know. You can refer your slides, Team Ritika, if that helps you.
Yeah, we're trying to do that.
Okay, no worries.
That's fine. You can tell me what is it? 581 megawatt hours or
It's 5,81,000 kilowatt hours.
sorry, 5,81,000
1,000 kilowatt hours.
kilowatt hours, right? 581. And what is the size of the plant that you have put for this?
On roof we have 293 kilowatt plant, and on the west facade we have 72 kilowatt plant.
Okay. All right. And you have validated that on the roof you will be able to get. You will be able to get 293 kilowatt.
Yes, sir. We have placed it on the roof to see how many numbers we can accommodate, and as per the specification from the market, we have calculated.
What is the roof area? Do you have off it? Do you have offhand? But somehow when I looked at it, it
No.
didn't look like a.
Priyanka, do you have it with you right now?
That's fine. I mean, if you don't have it, don't want to go. Are you using the area between two roofs also for solar PV?
No. We are
No,
putting
just
it
on the
only
roof.
on top of the auditorium. Yeah.
Okay, only on top of that. Okay, all right. So somehow, uh, so is the roof area at least about what 30,000 square feet, or so 3,000, 4,000 square feet, right? That much
Sir,
you
it
have,
is
right?
approximately 1400 square meter.
1,400.
Sorry, 2400 square meter.
2,400. Okay. Might be going a little tight there, but that's okay. That was one. And you also mentioned some energy, electricity production from something related to waste to energy. Could you elaborate a bit? What is that you're doing on waste to energy? Because this is something we have not seen in any of the other presenters. So I'm just keen to understand how you are producing energy from the waste in this building.
Actually, sir, we have taken few of the papers and a few of the studies regarding the refuse derived fuel as the incineration of inorganic waste through a plantation services. And there, the paper also produces almost like the organic waste from the hospital, like healthcare units, and then they produce those things as a refuse derived fuel through the incineration process, and they almost reach almost like 13% of their total renewable energy generation potential from that. So we have taken the consideration from that, and also few of the efficiency. I could not tell you the exact efficiency that we have taken from, but whatever accommodation like from inorganic and organic waste calculation that we've done on the basis of the capacity of 250 people. So according to that, we have generated those amount, and it is almost like 2 to 3% of the total renewable energy generation that we have on our site, apart from solar PV panel and biomethanation plant.
Okay, so it's a good idea. It's a very good idea. I've always been thinking why somebody doesn't do it, but
Because
I was
our
looking for a.
intention was to make it also as a zero waste site, not only as a zero energy, to make waste as low as possible. So that was the idea that we have taken from.
Okay, it's as I said, it's a good idea. I'm just I'm not aware. I mean, I would have liked more details. Once you incinerate, what do you produce and how that electricity produced? If you could provide, I mean, look into that, because from what I'm hearing, you are also not aware as to how exactly electricity is produced. I understand you want to use the waste, incinerate the waste. What happens after incineration is not clear. What technology you are using, but overall, a good idea to pursue. I mean, it's always good. Just be aware if there are any PCB norms that prohibit on-site incineration of such things, and if so, what needs to be taken care of. I think I liked what I heard, and your presentation of the report was good. Just some areas where I would like you to check your data. That's all. Thank you.
Great, guys. That was a really insightful comment. Do think about it. So let's now have jury Swati on stage. Yeah, please.
Hey, wonderful presentation, really nicely done. Very crisp, very easy to follow, and kept me, completely focused immediately after lunch. So good to have that. I have a few questions. You have mentioned in your report that there is 30% glare. There is glare probability in 30% of the spaces. So that is a very, very high number. And with 30% glare, you can't even consider it to be well daylit. That's one question I have got. Second thing is you can't even consider natural ventilation with that kind of glare, because the moment you have that kind of glare levels, you'll pull down the blinds and the windows get blocked off, both for natural ventilation and daylight. So I wanted to understand what you have done to counter that. When you do shading design, just what is the basis of your shading design? You gave very theoretical understanding of how you have done the shading design. It has to be a lot more. Can you explain how you have arrived at those shading strategies? And even after shading, have you achieved this kind of glare levels? Because you have said 0.5 meters. Why did you restrict to 0.5 meters when the glare levels were so high? Is the question I have. Second question, your rendering showed that solar PV was covering the courtyard as well, but you've just answered, Madhu, that it didn't. So where are we on that? Is it there? Is it not there? And if it is there, have you considered it in your daylight calculations? Let's get to these. Third one is Jali. How does Jali give you a Venturi effect?
So, ma'am, to answer your first question regarding the glare potential, so we have read your comments in the last deliverable. So after that, we have so in summertime, in Raipur mostly the sun is towards north. So we were getting most of the glare from the northern side into the building. So after that, we have incorporated jalis towards the northern side also, which helped us to reduce the glare from that side, and not with the blinds. And regarding the Venturi effect, because
So hold on to that. If you have put jalis, have you calculated daylight again?
we didn't get time to do that in this short time. But
because jalis would cut down daylight quite significantly. So you might not realize, you might not get that kind of daylight. So, and jalis might be a bit overkill on the north. Think about it.
Yeah.
Okay. It's always a balance between glare control and good diffuse daylight and maximizing natural ventilation. You cannot do one without the other. Okay, go on.
Okay. And for the solar panel part, we have not put solar panels on top of the podium. We have a space frame system that we had provided there. Maybe in the 3D visualization, it came out wrong. And about the Venturi effect, our predominant wind direction is from west, and that is also hot wind coming from that side in summer. So by providing jalis on that side, it because it has small holes, so the wind pressure was increasing. So that way the wind pressure was reducing and the velocity was increasing. So we thought of that while
You really
providing
think
the
so?
jalis.
You really think so? Any breeze, anything takes the path of least resistance, right? If there is a too much of pressure drop across the jali, it just won't work. Okay. So do read about that. Do a bit more research on that, on what you might have to look at the jali design itself.
Okay.
Okay. All right. To
Thank you,
actually
ma'am.
enhance. All right. So that's one thing. So that answers my question about solar PV. The rendering showed it, so it was a bit confusing whether you have it or don't have it. You said it's not there.
So in the calculations, we didn't count it.
You did not consider it. So when you are another thing in your design case and your base case, the equipment load reduced. And that was a bit strange because that shouldn't. Equipment load should be the same between design and base case, especially if you're removing equipment from ancillary spaces like corridors, that shouldn't be there in the base case either. So that's not an energy conservation measure. All right. So
that is how
be
we actually
careful
did the base
about the.
case modeling.
Sorry, say that again.
That is how we actually did. We were not aware of that. So in the base case, in the ancillary spaces as well, we have given equipments, office equipments, and then during zoning, we have removed them from those spaces.
So that shouldn't, then it shouldn't be presented as a energy conservation measure that it has reduced. And when you show the comparison between base and this, the equipment should be consistent. All right. The only thing that you can take is if you are proposing high efficiency equipment. Maybe then you can consider it, but otherwise you can't. All right. Otherwise, your water strategy was very good. Very, really nicely put together. I'm glad to see resilience being looked at on a multi-pronged way. Then again, one more question. Water table is very high. You said there are waterlogging issues. How do you think you can have recharge on site when you have waterlogging issues and you have high water tables?
Ma'am, waterlogging issues as in means as there is a stormwater channel abutting the plot. So if it is not properly maintained, then only there will be a waterlogging issues. Otherwise, it won't. And regarding the recharge, we thought of we do the borewell reach means we'll do the recharge through borewell pits. So that was our strategy that we have incorporated.
Do you think that's a safe strategy, borewell pits? Aren't you pushing untreated rainwater
No,
into
no, means it
groundwater?
will, no, at surface level, it will have grease trap chambers and all that. So
That's,
that
do you think that's sufficient?
we'll check it, ma'am, again.
Read up about it.
Yes, yes,
Okay.
sure.
All
Yes, ma'am.
right. Read up about that. So that's a, also when you did your CFT analysis, it's good to see CFT, but again, details. You know, devil is in the details. You have to look at details when you go, when you are going into details. Your conceptual development was great, but you'll have to look into details and understand what you're putting in and what you're suggesting and detail it out correctly. Spend some time on that. Okay. All right. So well done. Nicely put together. Lots of things that you have taken into consideration. The way that you've balanced all the 10 is very nice and very good to see. Good effort.
Thank you, ma'am.
Great
Thank you,
work,
ma'am.
Mithika. The reason you are getting such detailed comments is because you have worked so much. Cheers on that. So let's have Gyan on. Over to you.
Yeah, thank you. Very good work, as both Madhu and Swati said. Good concept with a combination of passive and active strategies. Little bit here and there, always scope is there to improve. Uh, Affordability also, only one aspect you have covered. Innovation, well explained, I would say, through analytic narratives. Indoor thermal comfort and IEQ considerations were well thought of. Uh, Only in water, while calculating, you have completely ignored the HVAC demand. So there is zero demand for water in HVAC. And while using the chillers, you have said VAV water cooled chillers absorption type. Now, I would like to understand from where you are getting this idea of using absorption type chillers and that too VAV combined. So that is a little bit. I don't know whether you uh, misprinted that or deliberately printed that. You can explain that, but uh, water cooled absorption chillers. First, water cooled chillers will definitely consume water. Second, absorption chillers need certain kind of heat. So, what is the heat source for that? And then it doesn't consume that energy because it runs on. It's a different technology than compression based. So it's not a kind of HFC or HCFC kind of refrigerant. It's basically either ammonia or lithium bromide based. So just look into these. If you have answers, you can give. If you don't have answers, please go through, do some kind of research. Then you will understand that uh, one, water cooled absorption chillers need much more water than any compression waste chillers. Second, we need some kind of waste heat to generate that because the COP of these chillers are less than 1 as compared to the refrigerant waste chillers, screw chillers if you are using, it is going to be uh, much better. 6, 7, and over and above, even if you consider the overall equipment wise, then also it is much better than this. And generally, if we are using electricity to basically or create heat by burning of any fuel, then it's better to generate electricity and use the compression waste chillers. So these are few things which you can consider in your future. Otherwise, very well explained, very good design, well presented, and well thought of. Keep it up. Good.
Adding
Thank you.
one point to Modgilji and Madhusudan, you know, waste to energy. There are several ways to look at non-organic waste. Do you think incinerating is the most? It might provide energy on site, but do you think it's the most eco-friendly option when you look at it from a holistic level? Do you think incinerating is better, or do you think recycling and is better? You need to think about it.
Yeah, but Swati, one thing I would like to mention here. Uh, Recently, we were doing pilot projects for retail cold chain through World Bank, where we have uh, sustainable cooling initiatives. So there, even hospitality also we had been doing that, and one American company, it's a in the pilot stage only, uh, TRL stage 8. They are reaching 9 now, but that has got an equipment which basically uses any kind of waste which generally is produced in hotels, and that waste is utilized through uh, basically it is a gasifier. Through that it is converted into electrical energy, and that we are utilizing for one of the projects in Maldives. That's what we have a plan to put a pilot out there, because there the waste
Yeah,
uh,
yeah.
is also a consideration where to throw that. So that
Yes,
is
yes.
utilized, and it in terms it gives energy as well.
Yeah.
So, and it's not incinerator, definitely is not a good way to go for, because that is ultimately polluting.
Yeah.
Right.
Yeah, but I disagree there a bit. They mentioned that there is some medical waste and all that, which would be incinerated anyway, right? If not at this site, at some other site. So if it is going to be incinerated, you might as well use its energy. But then again, I qualified it saying that check with PCB what PCB allows, what it doesn't allow. If PCB allows and your emissions are within PCB prescribed limits, by all means, you should use that heat. I don't know. I don't know how much of that is available at site. But medical waste, as far as I understand, is incinerated anyway, isn't it?
Yeah, medical waste is
Uh,
incinerated. Yes, it is. It is. Yes. So
Only a
it's
certain kind of.
it's a matter of actually again going into details,
Yeah.
Yeah.
understanding the site context, understanding what kind of waste, understanding what happens to that waste if there are alternative good recycling options, and then finalizing your strategy. So you do need to put everything into context and get into details.
Yes. So thank you,
Certain
Jimita.
Yeah.
Oh, sorry, please. Please, please, please.
certain norms have come in for medical waste disposal, and Pollution Control Board has taken certain measures to stop that incineration, because which used to be in generally in hospitals. So now even for all kind of waste, there is a procedure which is laid down, and there are uh, agencies nominated who are collecting those and have certain procedures laid out how to dispose of or get rid of that waste.
Yes. So adding
Anyway, good
to
work. Keep it up.
Good work.
adding to Gyan. So similarly, in Singapore is doing the same thing of incinerating the waste and taking out the energy out of it. So just to add up. So thank you, Team Mithika. You
This
launched
made it
a
right.
full-fledged discussion over here, right? And this was really interesting.
Yeah,
So
yeah.
thank you for
Waste
that.
incineration is a big thing, you know.
Yes,
It's what is
yes.
better. It's always context. Does just Singapore doing it, even in Hyderabad, it's being done lots of places, but is it the right thing?
Okay, great. So thank you, jury. Thank you, Tim Ritika. Yay!
Thank you.
Thank
Well
you,
done.
everyone.
Good work. So now we will proceed to the next presentation after a 5 minutes break. Hello, guys. So, our next presentation and the last presentation for this division is from team XYZ, or X is to Y is to Z. And let's have them on screen, please. Hello, guys. How are you? Please unmute yourself.
Hi. Hi, all
we're
good.
good.
All excited?
Yes.
9 months down the lane, right? Janvi, you can slightly adjust your screen if you would like to. Bring your, yeah, great. Okay, so we'll have a small A/B check, but before that, let's introduce you. So, Team XYZ has worked on the Ruby Phase 2 in Mumbai, Maharashtra. The project partner is Mindset Estates Private Limited, supported by Ruby Mills Limited and Access Architects. Okay, guys, let's prep up for a quick AV check. Uh, Kunvar, please say something.
Hi, am I audible?
Yes, you are. Great. Janvi?
Am I audible?
Yep. Get up, yeah. Nikhil?
Hi, I'm audible.
Volume.
Am I audible?
Yep. Good to go. Heta?
Hi, am I audible?
Perfect. Okay, guys, I think you're good to go. But before we start, some checklist. Okay, so you will have 25 minutes to present your presentation. Okay, in front of the jury. After 20 minutes, I will ring a signal like this. Audible? You will not have any minute after that, which means at 25 minutes, I will stop you and ask you to end your presentation. Okay? And after that, for 15 minutes, we will have a Q&A session. So please keep your answers direct and to the point. If possible, we would love if your project partner can join in. Rest, we are good to go. The stage is yours, team. Please project your screen. Is it there?
Yeah, just give me a moment.
Sure, no worries.
Is the screen visible?
Yeah, are you in the presentation mode?
Yeah.
Great. All the best, guys.
Thank you.
Thank you.
Thank you.
Your time is running, guys. Start. We can start, guys.
Oh, okay, all right.
Yeah.
So Team Access to Wise to Z is a group of 15 students, 15 students, 12 architecture students and 3 engineering students from 2 institutes, BSSA and Mumbai and IEM Kolkata. So the site that we chose is based in Mumbai. It's in Dadar, which is in a very close proximity to the ocean, the Arabian Sea. So the building typology that we were looking to construct or propose was the information technology cum commercial office building. It is supposed to be a phase 2 of the Ruby project as proposed by Access Architects with Ruby Mills. Around 11,000 occupants are to be expected every day. The hours of operations range from 10 to 12 hours for 6 days a week. The climate of Mumbai is tropical, warm, and humid. And as mentioned, there are different constraints that the site holds towards our design proposal. First one being the transit near and around the site. The site is in close proximity to Dadar railway station, which experiences a heavy footfall every day.
Expanding further on our site context, marked in yellow is our plot line, which is opposite to the Western Railway line.
which is opposite to the Western Railway line and the Dadar Railway Station, which reflects the most movement around the site. Then, marked in blue, are the bus stops which are near our site, which regulates around about 20% of the user movement which onto our site. According to the development plan, there is an incoming metro line, upcoming close to our site, which will also drive more users to the site. Lastly, the marked in green are the four access routes to the plot approaching from the primary roads, which are heavy in traffic.
So, talking about our workflow and design documentation process, our initial idea was to start off by analyzing what the site holds, the opportunities, the constraints, and the drawbacks of the site, and how to adapt to them or overcome them in a way. So we started off by knowing the client's requirements as well. Since it was a phase two, they wanted a building that was identical to the phase one, which they had already built. Talking about the SWOT analysis was majorly determined by the climate analysis of the site, as shown on the right. So there were different constraints that we were looking at. The first one being the sunlight. Since the building is a high rise, sunlight plays an important role. So through the sun path studies done on our site, we concluded that there's ample sunlight and shaded spaces available on site, with some spaces that were fully exposed to the sun and some spaces that were semi-shaded spaces. Talking about the radiation, most of the radiation received on site was on the southern edge, and that was indirect radiation that was received on the site. Lastly, talking about the wheel analysis, we got to know that the the major wind direction is from the western edge, and it comes between the months of March and October.
So we have taken into consideration 8 goals and strategies, being energy performance, water performance, health and well-being, innovation, resilience, affordability, scalability and marketing, architectural design, and comfort and environment quality that the building has. So, coming to the design development of the building, the form of the building was highly determined by adapting to the external forces such as wind, humidity, rainfall, sunlight, etc. So, one of the core issues that the site would face, being a high rise, was the vortex shedding that the building might face. So, we came up with different solutions which could help in tackling the vortex shedding, one being staggering the corners, another being twisting the building, the third being tapering of the building, and the fourth being an oscillating ball on top to tackle the vortex shedding. So, one of the experiments that we did with the form was to start off with a solid block, and then, as I'd explained, we started to stagger 2 corners of the building, which was the second process, and the third process was to give this twisting form to the building so that it creates like this sort of a pathway to push the air upwards and tackle the vortex shedding. And we also used softwares to sort of understand how this particular form would be more efficient in order to tackle the vortex shedding. But this particular form was not very feasible in terms of the cost of construction. So we came up with another design for the form. Um, So the plot area given to us was 3,740 square meters, and the building follows the geometry of the plot. We added these staggered corners, which help in the to tackle vortex shedding as well as give green decks. The building is made up of flat slab construction, and there are 2 service cores that run centrally for circulation. And the building is cladded using a double skin facade system.
So these are a few micro level design development ideas that we considered while designing. First, being the double skin glass panels that we used for the facade, which is a sustainable solution which can be adaptable to all weather conditions. So, the double skin facade system consists of a fixed exterior glass, an operable interior glass, and the vents for the inlet and the outlet of the air. Solar panel films are also coated onto the exterior skin to block the harsh solar radiation and also reuse to generate electricity, which we will be expanding further.
So the fish mouth is a additional element that we have added onto the double skin facade, which helps in the intake of cold air from the bottom vent. And since the interior facade is openable, it allows the entry of cold air inside. And the top fish mouth is used as an exhaust for the hot air. So through this, we allow a circulation of wind, and we can use this hybrid system of also using natural ventilation inside the structure whenever needed.
uh, we considered few strategies for the interiors as well. So one of them was the for the interior walls, which was the hydroceramic walls, which works as an evaporative cooling system, which can reduce the temperature by increasing the humidity, which will lower down the indoor temperature by 5 to 6 degrees. We did not end up using that for our final design, considering that as it works by the idea of increasing the humidity, which was not ideal for the weather conditions we have in Mumbai.
Green walls are another element that we've used in our design because green walls allow cooling of the wind that the building experiences, and also it adds an aesthetic element to the building itself. So coming to the area allotment and calculation, so the total plot size that was given to us was 25,000 square meters, and there was a height restriction of about 50 floors. And the ground coverage that our building takes is about 3,734 square meters. So considering the FSI for commercial buildings in Mumbai, which is 5, we come up to a permissible built-up area of 74,354 square meters. And adding a 35% fungible FSI for commercial buildings, we go up to 1 lakh 377 square meters of built-up area that is available to us. Yeah, so coming to the program list that we have for the building, we have given workspaces, gathering spaces, server room, cafeteria, event space, boardroom, AV room, training room, and conference room. And coming to the service rooms provided, we have toilets, refuge areas, tune stations, pantry, and AVS rooms.
So this is a site plan of the Ruby Phase 2. So the marked in green, the light green, is the staircase that leads us to the lobby on the upper floors. Landscaping is provided on the site, and there is parking which is in peach color. So we have parking in the 5 floors, 5 stilt levels, and 3 in the basement. And the marked in blue are the service areas. We have two main cores which runs along all the 40 floors, uh, which I will explain further in the next plan. So this is our lobby floor plan. We have around 16 lifts in the core, and WCs are at an equal distance so that it is accessible for everyone at a comfortable space. In the lobby, we have also provided other activities like cloud kitchens and restaurants. So it is more of a commercial space, and the office floors are added onto the floors above. The parking also connects to the floors till 5 level to the building at 5 levels. So this is the basement plan where there is parking provided and other service rooms like driver's room and fan supply room for the ventilation. And there are two slopes that takes to the floors on the parking above, One is on the top left corner and one is on the right side. And we have other services provided as goods elevator, which is onto the right side of the building, which goes up all the way to the 40 floors as well.
So coming to the typical floor plans of the building, the functions that we've given on a typical floor plan are the central lobby, the office spaces on the two sides that the lobby divides the building into. We have conference rooms, cabins, training room, AV room, a server room, and you have service areas such as toilets, lifts, ducts, and goods elevator which are present. We also have the staggered decks, which have been marked in green at the corners of the plan, which come at every seventh floor up till the 21st floor, and the seventh floor at each seven at an interval of 7 floors, we have the refuge area given, and also the seventh floor acts as a recreational space where we have the canteen and an activity arena where the users can play games like carom, billiards, etc. So these are the other typical floor plans, and as I had explained, the staggered decks keep changing at every 7 floors. And as you can see over here as well, you have the seven at every 7 floor. You have these recreational floors that uh, are functioning for those 7 floors.
Okay, so now we move on to the actual design of. So we start looking at solar. So we propose. So we have a roof area that is already available to us, and we do some calculations, and we treat the fact that 70% of the roof may be usable as for solar panels, and with the kind of sizing that we do and the radiation that is available in Maharashtra, in Bombay, we use those numbers, and we find out that we can get about 80 lakh kilowatt hour per year of total energy that we can generate through the solar panels annually. Yeah. In terms of daylighting and radiations, the diagrams aren't loading. Just go next. So yeah, so we just have the analysis of daylighting and radiation to understand kind of positioning of the sun that will be. So we do it at multiple floors, and we see the kind of radiation that is expected, and the number of daylight hours that each of the facades will experience. Using this kind of data, we started using something called BIPV. We proposed BIPV, which is a building integrated photovoltaics. So we proposed using of thin films for the same reason. And what we did is we used a software where we iterated certain ways in which we would position the cells. So the thin film cells that we propose in using is the crystalline silicate thin film cells. And the reason we choose these is because while they are a little less efficient than other competitive, other types of different thin films available, but it's much cheaper. And the other thin films also use harmful elements like cadmium, which don't decompose that eco-friendly. So using that, we come to about 7,46,000 kilowatt hour per year that these solar films themselves can generate.
So coming to water cycle, water was an essential part of our research and our design proposals. So we started off with a water cycle that showed us where the usage of the total amount of water goes and what is the outcome. So we realized there's a need for STP, two STPs based on the outcomes, that is the gray water STP and the black water STP. So we designed a closed water cycle within the site wherein the total water restored is more than the total water demand. This was our aim, and this was based on the idea of each occupant getting 45 liters of water as per the Griha indications. We have ensured 100% of waste water being treated by natural STP system, which I'll elaborate on further. We have achieved the above through the following strategies, the four main strategies that we adapted: reclamation and reuse of 100% of wastewater, rainwater harvesting, on-site water treatment, utilization of efficient fixtures. One important thing to note here is that instead of having a storage tank for the runoff water, because the groundwater table of Mumbai is depleting rapidly, we chose to recharge the groundwater instead of storing it in tanks. So, talking about the water usage, as mentioned before, each occupant gets a leeway of 45 liters of water as per the GRIA indications, and we try to reduce the water consumption through the four applications by 74.2%. So the rainwater management, because Mumbai receives rainfall between June to October, we thought the rainwater management could become an essential part of the design. So to increase the surface runoff, the roof surface, hardscape and softscape as our catchment areas, and we've implemented something called infiltration galleries that help us in retrieving as much rainwater as possible, which again goes to spaces like softscapes. Spaces like softscapes have also we have also put in native plants and trees that do not require high maintenance in terms of water and yeah, in terms of water requirements. Talking lastly about the sewage water treatment. So sewage water treatment, we've used something called tidal flow constructed wetland system that helped us not only looking after sewage water treatment in terms of black and gray water, but also helped us in having a softscape that was efficient and responded and adapted to the site accordingly. So the black and gray wastewater has been segregated and treated independently within the site through the system of tidal flow constructed wetland system. So within the settling tank, that is the very first tank of the tidal flow constructed wetland system, it removes the coarse solids and floating material, plus it equalizes the flow of water for the next stage, that is the treatment media, which is the very first stage after the settling tank. Over here, through the treatment media, the smaller particles in water get segregated and move towards the finer treatment media, where bacterial or the where the tidal flow cells are where the bacterial elements are eliminated. Lastly, there's an additional UV treatment or a polishing tank that's added to the entire system, where the gray water is treated and can also be used for potable purposes later on.
Yeah, so when we were looking at HVAC, we started looking at VRFs, which is variable refrigerant flow type of cooling. So in this, what happens is you have a VRF unit, which is your water cooled VRF unit. So we propose a water cooled system that is in one circuit connected to your cooling tower, in another circuit connected to each of your individual air conditioners. And the advantage of this is, since the office has, first of all, a lot of footfall, but it varies depending on the room usage. And over the period of the day, certain rooms may be, yes, less or more used. So the VRF system has provisions for reducing with the frequency drives that are available in the VRF unit. It varies the frequency, and you can control and save energy if certain rooms are not being used while certain rooms are being used. Again, in terms of the BIPV, it along with the fact that it helps generate power, as we discussed earlier, it also acts as a sort of a passive shading device, because these thin film cells are not entirely opaque, but they are not transparent either. They are translucent cells, so they'll reduce the kind of harsh sunlight that will be coming into the office, which reduces the kind of heating effects that take place inside and reduces the load of the HVAC. We also, as we've talked about, the double skin facade that we have, which we'll discuss later in the construction details, and there you allow natural air to also enter and be vented out.
So, as I had mentioned earlier, we had these staggered decks that were placed, which help not only in tackling the vortex shedding that the building uh, uh, faces, but also it creates like a favorable microclimate for the building itself. And in these spaces we also allow like the wind to enter the building to give natural ventilation to the building. And as I had mentioned earlier, we have also used green walls near the podium to cover the facade of the podium because it adds an aesthetic value and also cools down the wind that enters the building.
So the site water supply plan. To determine this, there's a very basic plan that we made that showed this inlet of water supply on the site. So the water supply is mainly provided by the municipal water line. It comes through the site through a stop valve and a PRV, that is a pressure reducing valve. It goes straight up to the UGT that's placed on the southern edge of our structure, which is adjoined to a pump room that further helps the water uptake towards the OHT. Um, Talking about the OHT that's placed on the terrace of or the roof of the structure, as per the guidelines, we've given one third of the tank quantity for flushing and two-thirds of it for domestic use. Further, the OHT serves to the rest of the floors through a downtake pipes that is present on the four ducts that we've provided near the cores, the two cores. There's a brake tank that's put up at every level so as to look up for the water supply systems.
So this is the lighting plan of our typical flows. So where we have the MDB and SB.
Sorry.
MDB that connects to all the main supply boards also. And on the right, we have the lighting placement that different types of light use in the rooms according to how much lumen is required for every room. This is a firefighting plan where we have maintained a maximum of 30-meter distance between every emergency staircase. There are other elements provided in the fire safety, which is like the sprinklers, which come at every 1.5 meters at max. Dry powder sprinklers in all the service rooms. Then there are these portable extinguisher, hose reel, sand bucket close to the fire exits, heat and smoke detectors at every 3 meters maximum, fire exit signs everywhere marked in neon, and fire hydrants around the site with the CME's connections. And all the service walls and emergency staircase walls are protected with fire retardant walls.
Since we have 3 floors of basement parking, it was necessary for us to mechanically ventilate the basement, and hence we have given a layout of fan supply and return rooms by dividing the basement into an areas of 500 square meters, which will and within each 500 square meters there is a pair of fan supply and return.
As you were explaining about the VRF system, so we have two different AHU rooms that we have available in the service floors, and we've placed our outdoor VRF units in those, and then they further connect into the individual air conditioning units all across. Um,
Sorry, guys, you have used your slot of 25 minutes. We'll have to stop now. You have any ending remarks? Just go through the slides if you would like to.
So this was a further detail of the double skin facade of how it actually works with all the inlets, fish mouth, and a flat slab system that we have provided, and how it naturally ventilates the entire room, which also can reduce the air conditioning cost in the entire building whenever it is possible.
Cool. Just run through the slides, please.
Yeah.
Sorry for this interrupting, but then we have a time limit, right?
Yeah, this is just the last slide where we are talking about the tension state column detail to support the 7 floor high volume of the green space, and how we have sort of helped to tackle the slenderness of the column and increase the compressive strength of the column.
Okay, great. So we'll have the Okay. Jura's on stage now. We will stop projecting the screen.
Sure.
So thank you, team. It seems like you have done a lot of work. So 30 minutes was not enough. We will surely have another session. But right now, let's proceed to the jury members. We will start with Gyan this time.
Yeah, good work. Uh, Good ideas. You have considered various aspects which generally uh, are appreciated. And water use also you have minimized. It's a good thing. And natural treatment, yes, a very good initiative without energy. Thermal comfort wide also, I think it's well done. Now, I have few observations in the sense that BIPV in a kind of location you are considering is not that effective as the roof panels are because uh, horizontal receipt of solar PV or uh, performance of solar PV is much higher as compared to the vertical frame. Now, you said you are combining it with natural ventilation and trying to use cooling effect of that. I would only like to emphasize upon the point that this generally is used in a cold climate because when you integrate the BIPV or solar PV with your facade, then solar PV gets heated up. And then either you utilize that heat for heating in cold climate or you throw that out. So you have both the options to pull the air from bottom and throw exhaust or let it in into the space. But that is a hot air. So in Bombay, you are not going to get that kind of benefit which you envisage. So you are using uh, VRB or VAV, water cooled makes it more efficient. But at the same time, VAV fresh air aspects need to be looked into because generally VAV units, the kind of you have shown the units which are ceiling mounted, do not have much of fresh air intake. And if you allow outside air to get in, then the condensation is an issue, which generally happens in Mumbai like atmosphere, which is quite humid. And when you are putting your uh, VAB on the outside, so and you are using cooling tower, I would
I guess there's a small lag. Um, okay, meanwhile, Gyan joins in. We will have our next jury. Swati, please, would you like to commence?
Yes, yeah, sure. Um, Modgilji was talking about condensation. So I'll let him finish that. I have a few points to add on that as well, but let him finish it. But a couple of things in your form development. You talked about vortex shading. What exactly do you mean by that? And you've done all the form exercises that you've shown. One, which form is good from a theoretical level, but the wind flow analysis that you did doesn't show or doesn't support any of that work that you have put together that you have shown either in the presentation or in your report. So I was wondering whether you did support it or support your conclusions with the wind flow analysis or not. So that's one question. Second question I have is you said you have a double wall system, right? And external is fixed glazing and internal panel is operable. If external is fixed, where is the fresh air coming into the cavity from?
So in terms of the double skin facade, we spoke about the fish mouth element. So if you see in the diagram as well, Janvi, could you maybe share the screen?
Yeah, I'll just share my screen. Is the screen visible?
No.
It will come on screen the minute it is on the presentation mode.
Oh, okay.
Yes.
Yeah. Just
Well,
give me a moment. I'll present the screen that he's talking about.
Yeah, so basically, if you see in the outer facade, we have given this inlet on the top and the bottom part through which you allow the wind to enter into the cavity, and then afterwards, the second layer is openable, so you can allow that air to come in, and the hot air can go out, which is there inside. So that's how we're allowed
Do you
the.
do you think that's sufficient? Do you think that small opening there is sufficient for number one,
So,
ventilating that cavity, number two, providing fresh air?
so, one of the reasons that we've given it as a small cavity is because of the high wind speeds, because it's like a 40 floor high structure, the and since it's closer to the sea, it experiences a lot of wind. So rather than having larger openings in order to sort of control the amount of wind force that will enter into, we gave these smaller inlets that sort of run. But near the green plazas which we had shown, there are openable windows that are present. So like you can have because the green plazas end only at 21st floor, they don't go higher than that. So the amount of wind that the building experiences is less on the ground. So hence we've given completely openable windows over there. So
Hmm. Given the size of those openings, given the fresh air, because you're saying that also provides fresh air into the rooms, given the size of your openings, ventilation, what Mothgilji was talking about in terms of picking up heat on the way into the spaces, I think I think you need a lot more analysis to make this work, or you need a lot more work, you need a lot more analysis to understand how it works first, check whether it is workable or not at this particular climatic condition, and then look into it. So in the present form, it doesn't have enough data backing it up that it works. So you'll need to the fresher requirements, that's the only fresher requirement you're talking about, a very little. That's the only, apart from the what you have proposed, otherwise as per the cooling system, but this is very little fresh air. I don't see this being sufficient in any form. So you do need to detail this out. You do need to understand. You need to analyze it using CFD of the double cavity wall before you can even take it forward. That's one thing. Second thing is I see no solar control except in the form of those BIPV. Do the BIPV, are you proposing to have BIPV on all facades?
No. So there was a diagram that supported as to where we're going to put our BIPV sheets on what all facades. Let me just skip to that slide. Um, is the diagram visible?
Yeah.
Yeah.
Nikhil, do you want to take this one out?
So basically, we wanted to place the BIPVs on the west, south, and the east facades only. So uh, uh, more towards the uh, yeah, more towards the west and south facade, so that because the east side is you have these structures that block the amount of sunlight that falls on the building itself. So we've placed only on those because during uh, like these two facades are the facades that gain most amount of sunlight. So we've placed the BIPVs on those facades only. And in
Well,
north you get indirect light, so we've not placed on the north.
north is not just indirect light, it has direct sun as well during summers. So you do need to look at, I don't, how are you managing to do provide thermal comfort and visual comfort? Because those don't seem to have been addressed very well, and BIPV only on south and southwest. don't really provide you sufficient. And what about the other facades, east, north? Those don't seem to have been worked out. And when you do, please, it'll be good if you can go ahead and analyze it properly, understand how much BIPV is providing in terms of visual comfort and thermal comfort, and then design accordingly. Maybe you need to add shading devices within you have a double cavity wall. You can provide shading devices within that, right? To provide improved visual comfort and thermal comfort. That's something that could be done in a tall high-rise building like this. So I think you need a lot more thought that has to go into that facade, because for a building of this kind, facade is critical. And you do need to put a little more effort and thought in the design of that. That's one thing. Second thing is, what do you mean by infiltration galleries that you have suggested?
Yeah. So I'll. Should I stop sharing?
Yeah, sure.
Yes, please, if you'd like to.
Yeah. Infiltration galleries are basically these systems. So it is like a subsurface source of water that is used for a water supply, like whose structure is, so it's a horizontal drain that acts as a water supply system that's been implemented at like it's a new technology that's been implemented in various public spaces. So the horizontal drain can be made out of an open jointed pipe or like a perforated pipe. So the water that's collected through this pipe can be taken to a sump or a collection point and then to a storage tank. So it's like a small, it's a horizontal perforated pipe that allows for water intake and storage of water at various points.
Okay, that's an interesting thought. That's an interesting idea. Did you do any? I don't see any energy analysis. You seem to have missed out on doing the energy analysis. Energy, have you built an energy model? Have you run the studies? Have you calculated your loads? Have you calculated EPI?
No, we weren't able to achieve with the size and the multiple amount of strategies that we had. Yeah, we weren't able to achieve.
Okay, all right. Okay. I'll let Modgilji continue.
Thank you, Swati. Please.
No, nothing much. I think, I don't know. Basically, it was only VIPV, which generally was, Swati also described that in great length. Only ventilation, I was trying to say that ventilation through that is only for heating application, because it's generally used. So in cooling application, it doesn't have much, because it's heating which is done while solar PV is acting as a source of heat. So the hot air is utilized in winter climates for this application. Nothing much on that. I think most of the points are covered by, and I leave it to Madhu to cover the rest.
Sure, sir. First, let me say that actually it would be it is a challenging building to design, because so far everything that we have seen, I mean, nothing we have seen so far is of this size. So it is a challenge to make such a vertical building net zero. So I just to be clear, I know you said you have not calculated, but are you claiming that this big building is net zero? I think that is the purpose of this entire challenge.
With the strategies that we have, since we don't have the design data to back it up, we can't obviously 100% claim, but we thought that with the strategies that we had, both actively and passively, we hope that it would be able to achieve the goal.
Okay. So yeah, I mean, even if it were, it will be very difficult. I mean, almost impossible for a 40-floor building with the kind of facade you have and the cooling loads it will have for it to be a net zero building. So still, you made an effort. That's fine. Just again, will reiterate. Good to use that double skin facade, but please understand what exactly you are getting out of it. Okay. To hope is different, but to you have to calculate, right? I'm sure there are benefits to it, but quantify those benefits. Okay. Um, I do like your tidal flow constructed wetland system. Um, though my knowledge on that is limited, but I feel that is something you have brought into this. I am not sure for the land that is available whether that is sufficient to treat the waste or grey water that you plan to treat. If it is so, good. Okay. On the solar front, you have taken 5 kilowatt hour per square meter per, per 5 kilowatt hour per kilowatt panel, right? Seems really high. None of the panels that I know deliver that sort of performance, but then I back calculated to understand how you have taken. I think that is coming from your 1226 watt per square meter, and that you have assumed as a constant throughout the year. So only if you assume that as a constant throughout the year, you will get the number that you have projected. So just so, since you all know that it is not constant throughout the year, just recalculate that to understand what is the exact amount. I think you said 80 lakhs, but I think you meant 39 lakhs of kilowatt hours of output. So that may come down a bit. Again, on BIPV2, you have to take the shading coefficient into account because it would be dynamic. Bombay being below the Tropic of Cancer, there'll be some shading. Even if you put it on the south facade, right? In the summer months, the sun would be behind, right, on the north side. So I don't know what would be the output of BIPV. Okay, these are my comments. On the whole, I would say for a building of this size, a lot of work is needed, and that I didn't see. That's my thing, but good attempt.
Good effort, guys. This was a challenging task, and I'm sure you have learned a lot through this. So cheer up. All well. So thank you, jury. Thank you, Team Ritika. So this was the last presentation, everyone. And we can, Team Ritika, you can step down while we have our jurors, right? Now, so since this was the last presentation in the office division, our esteemed jury panel has also shown a dedication in assessing these entries. I want to thank the jury members for your thoughtful assessment and comments. Oops. And I want to and I want to congratulate all the finalists again. I will stop the applause over there. So thank you, jury panels. Thank you.
Thank you. Pleasure to be here.
Thank you.
Quick question: do we connect again?
No. I will just share you what we are supposed to do now. So as the jury coordinator of this division, I had the opportunity to see these teams submit their deliverables 1, 2, 3, and the final one, 4th. They have done some incredible work. Let us not forget that these teams have discovered a way to collaborate and do integrated design while being physically away from each other during the last 8 months. I think that itself deserves a round of applause. I'm not going to play that again. So this evening, the jury members will meet and decide the winner and runner-up teams. So who will it be? So stay geared for that. Meanwhile, please make sure you have given your vote to the People's Choice Award, Movie Award, and feel free to hang around and meet the jury members and other guests in the networking zone in the lobby. And you can see the work of all the teams in all the divisions displayed in the project exhibit hall. You can access that hall from the main lobby. Lastly, we have a winners gallery for you where you can explore last year winners' work and runners up work as well, and obviously the grand winner. So, okay, guys, see you around. Thank you.